Well, good morning, ladies and gentlemen. My name is Bhavita Singh, and I'm your virtual host. Well, as it is said, you don't choose time you live in, but you can choose who you want to be. Welcome to the sixth season of Tata Steel Women of Metal, a pioneering scholarship program of Tata Steel aimed to induct bright young women engineers into manufacturing sector. The idea is to foster collaborative environment among students, academia, and corporate sector and provide unique and aspiring career opportunities to the young talent of India. Well, ladies and gentlemen, for the grand finale, we have shortlisted 10 candidates who will present their innovations in technology to our jury members. The entire journey started with thousands of registrations from 55 premier tea schools of the country, amongst them, top 50 completed 1 month project with assigned Tata Steel mentor. Well, top 10 identified through pre-finale. Identified 10 will be competing today against top 3 in grand finale. Before we move further, it's my honor to introduce you all to our jury members. First of all, would like to thank them for giving us their precious time today. Thank you so much for your presence. We truly appreciate it. Well, ladies and gentlemen, our first jury member is Mr. Anurag Saxena. Mr. Anurag Saxena currently holds the position of Chief of Electrical Maintenance of Tata Steel Jamshedpur. He is leading a team of more than 2,000 employees and around 1,500 contract workers to manage the electrical maintenance and power systems of Tata Steel Jamshedpur plant. He is a graduate in electrical engineering from IIT Roorkee and certified energy manager by Bureau of Energy Efficiency and an MBA with an advanced diploma in operation research. Thank you so much for joining us. It's an honor to have you here, sir. We have amongst us Mr. Satish Kumar Tiwari, Chief of Mechanical Maintenance at Tata Steel, received his mechanical engineering degree from Birla Institute of Technology. He's been associated with Tata Steel for about 20 years now. Well, I would also like to welcome Mr. Srujit Sinha, Chief Agglomerates at Tata Steel, received his bachelor's in engineering from National Institute of Technology, Jamshedpur, and majored in business administration from Exeleri, Jamshedpur. He has been associated with Tata Steel for more than 20 years now. Welcome, sir. Thank you so much for joining us. We also have amongst us Mr. Sisendu Mukherjee, Chief of Operations at Tata Steel. He has 22 years of experience in manufacturing, marketing, and sales, procurement, and total quality management. He has done his Bachelor of Engineering from IST Shipwood and have advanced diploma in quality management from Mahindra Institute of Technology. So once again, can we have a big round of applause for our jury members? Once again, I would like to thank you for extending your support to this event. And now, there are some ground rules that we have to keep in mind for the grand finale. Participants will be added at the allocated time only, one after another. So the next candidate will be waiting in the lobby for his or her turn. Presentation time is strictly 15 minutes. Yes, it's 15 minutes. You have to abide by that, followed by question and answer. That's for 5 minutes. So it makes it total 20 minutes for each participant to present. And the criteria of evaluation would be understanding of the problem statement. The scores would be out of 30. Problem analysis, again, scores would be out of 30. Recommendations, scores would be out of 40. Final rank will be determined on the basis of the total score. That will be out of 100. So we request all of you to please present whatever is there in your mind and explore your potential today. Well, thank you so much. And now, I think we all are ready, isn't it? Well, I would like to begin and I would like to invite our first participant. Please put your hands together for Ms. Sushma Vimnuri. Can we have you here, Sushma?
Good morning, ma'am. Good morning, ma'am.
Good morning.
Ma'am, am I audible?
Yes, you are, but if you can be a little bit more louder.
Okay, ma'am.
Yeah, it's okay.
Ma'am, is my presentation is visible?
Yeah, it's visible.
Good morning, sir. I am Sushma Vemanuri from IIST Shipur. With your due permission, I would like to present my presentation on improving the performance of electrostatic precipitators. Moving to the flow of presentation, it contains understanding the case statement, electrostatic precipitators and introduction, actual performance analysis of ESP at TSK, identification of various factors influencing the performance of ESPs, recommendation of an alternate solution, and finally the conclusion. Now moving to the understanding the case study. Sintering is an agglomeration process of fine mineral particles into porous mass by inefficient fusion caused by the heat which is produced by the combustion. Iron ores, limestone, coke breeze and many metallurgical wastes are converted into agglomerated mass at the sinter plant which forms 70 to 80% of iron bearing charge in the blast furnace. This entire process seems to be very simple, but many safety measures are taken as this process is entangled with burns, fire, smoke, gas, etc. One of the measure is using ESPs. These ESPs are nothing but the electrostatic precipitators used for removal of dust with exhaust gases from the steel plant. In this case study deals with ESP performance check, factors affecting its performance along with some ways to improve its performance. And this animation shows sinter making process at the TSK. And next, moving to the operation principle of electrostatic precipitators. These electrostatic precipitators utilizes electrostatic forces to separate the dust particles from the gas to be clean. In ESP, a strong non-homogeneous electric field is generated between a pair of electrodes under a differential voltage of 50 to 100 kilovolts. Generally, ESPs are having two electrodes. One is collecting or positive electrode, which is an assembly of vertical metal plates and grounded, and other is negative or emitting electrodes, which is an assembly of metal wires. The electric field is strong enough near the negative electrode and is able to ionize the gas into positive and negative ions. And these positive ions move toward the negative electrode and negative ions move to the positive plate electrode. During this trip, these negative ions collide with the dust and in turn charge them. These dust particles move towards the collecting plate electrode and they were removed via mechanical hammering or wrapping mechanism. This mechanism helps for the dust to fall into the hoppers under the gravity, and this animation shows collecting of dust onto the plates, and this shows the wrapping mechanism, and this shows the collecting of dust into the hoppers. Next, moving to the actual performance analysis of ESP at TSK. ESPs used in TSK are of two types. One is the plant dedusting gas ESP with 3 fields each for which the suction points are near conveyors, and other two are process gas ESP with 5 fields each for which the suction points are from sinter machine. The dust extracted from both the gases are reused for sinter making, and the gas entering the ESPs has many components like alkali, chloride, oxygen, carbon monoxide, etc. Each of these components has its permissible limit for the emission, and this data shows the performance analysis of ESP for the month of April and May 2022. It shows that in the month of April, oxygen has crossed its permissible limit, and in the month of May, oxygen, alkali and chloride has crossed its permissible limit. Suspended particulate matter or SPM is the finest hazardous particles, and this graph shows the analysis of emission level of SPM for the month of April and May 2022. And next, moving to the factors affecting the performance of ESPs. The factors like flue gas velocity, resistivity of particulates and transformer rectifiers or wrapping motors affect the performance of ESP. The velocity or gas volume, it is nothing but the ESP will operate best when the gas velocity is within the typical range of 3.5 to 5.5 feet per second. A decrease in gas volume will also result in the increase in collection efficiency, and it also increases the specific collection area. A decrease in gas velocity will result in good treatment time, that is nothing but getting charged and collecting mechanism. It also reduces the re-entertainment process, and the collection of the particles in the range of 0.1 to 1 micrometer range takes place well in the ESP. And this velocity is maintained by gas distribution schemes by evenly distributing the gas across the inlet of the precipitators. And these animation shows the working of gas distribution schemes, and the graph of gas volume versus penetration shows as the volume of gas increases, penetration gets increases. And the other factor is resistivity of particulates. The preferable range of resistivity is 10 power 8 to 10 power 10 ohm centimeters. If resistivity is too low, that is less than 10 power 8 ohm centimeters, flow of dust will be re-entrained into the outlet. And if the resistivity is too high, that is greater than 10 power 10 ohm centimeters, back corona will be formed on the plates. This resistivity depends upon temperature, dust composition and particle size. And the other is transformer rectifiers or wrapping motors. TR sets will be controlled by EPIC 3 controllers mounted in the TR panels. Wrapping mechanism is driven by wrapping motors, and these were also powered from the TR panels. Next, moving to the brief information about the factors affecting the performance of ESPs. Resistivity, it is measure of how easy or difficult for a given particle to conduct electricity. The higher the measured resistivity, the harder for the particle to transfer the charge. This resistivity depends upon chemical composition of the gas stream and the moisture content of the gas and the temperature. The preferred range of resistivity is 10 power 8 to 10 power 10 ohm centimeter. It should be kept in the reasonable limit for the good performance of ESP. And the other is dust composition. Carbon is highly conductive, and because of its low resistivity, so it can easily get charged, and it easily loses the charge quickly, so there will be a chance of re-entering into the outlet. This chemical composition of particulate matter will influence the range of resistivity with which the ESP should operate. The presence of certain compounds like alkali, chloride, sulfur are used to predict the resistivity problems. In addition to this chemical composition can also vary the particle size. And like if the particle size is above 1 micrometer, field charging dominates, and if the particle size is below 0.1 micrometer, diffusion charging dominates. And the ESP will operate best when it's in the range of 0.1 to 1 micrometer. And this shows the process design parameters of ESP, like gas flow rate is 184.3 meter cube per second. Suction pressure is minus 200 mm water column, and inlet temperature is 75 degrees Celsius, and emission is less than or 100 milligrams per normal meter cube. And this graph shows the resistivity of several dust at various temperatures, and this graph shows the effect of changing temperature on the efficiency of ESP. Next one is the control of transformer rectifiers. A TR set is a power supply used to step up or down the voltage and convert AC to the DC. There are 3 number of TR sets provided for each ESP. Rating of each TR set is 2700 milliamperes 110 kilowatts. These are located on roof of ESP, and each TR set will be having a control panel equipped with EPIC 3 controller. It is a microprocessor based unit for regulation of power to the field. It also maintains the spark rate of field to maintain the gas flow temperature based on the ratings of a TR. Wrapping motors. Wrapper motors are provided for collecting electrodes, emitting electrodes and GD screens. The purpose of these wrapping motors is to dislodge the dust that accumulated on the collecting or emitting electrodes and GD screens. There are 7 wrapper motors per each ESP. 3 for the collecting wrapping motors, 3 for the emitting wrapping motors, and 1 for the gas distribution wrapping motors. And this image shows the transformer ratings of a transformer plate at TSK. See, fundamental problems like resistivity, size, and mechanical problems like alignment, leakage can be overcome by proper construction and design of ESP. But operation problems like power supply and failure of TR will affect the working of ESP. So these are the recommendations to overcome this. The very first one is introducing Coromax technology. This Coromax micropulse power supply is a family of high voltage power supplies for electrostatic precipitators. Its main aim is to reduce dust emissions and less power consumption. These are also extremely efficient to collect hazardous fine particles like PM1 and PM2.5. Moving to the operation of the Coromax micropulse power supplies. These micropulse power supplies generate a special voltage waveform in the electrostatic precipitators, which is characterized by smooth base voltage superimposed by extremely narrow pulses. When operated with conventional DC, normal TR or switch mode power supplies, there will be emission of high resistivity dust into the outlet due to formation of bad corona. For this, these micropulse power supplies are used to use of this on a top of a base DC voltage that can reach up to 60 kilovolts. Micropulses are superimposed with a normal pulse width of 75 microseconds and an amplitude of 80 kilovolts. With this pulse energization, peak voltage gets increases to 140 kilovolts with a pulse repetition frequency of 100 pps. Moving to the features of these micropulse power supplies, current can be controlled independent of high voltage, and these narrow pulses allows the ESP to reach higher voltage levels, improving the charging and collection of small particles. These narrow pulses and high voltage levels cause a more intense corona discharge, which results in better current distribution inside the ESP. MPPs are also able to generate pulses which are narrow enough to influence the mechanism of discharge and therefore increase the breakdown voltage of the gas. The achievable peak voltage is even higher, which yields to an even higher filtering efficiency of the ESP. Because of the higher peak voltage, an ESP powered by MPPS has higher total mass efficiency compared to the other classes of power supplies. The installation of MPPS has succeeded in reducing the emission levels caused by high resistivity dust to the levels required by the law, and this solution was found to be cheaper and required a shorter time than the other solutions like extension of the ESP. It has many advantages like its efficiency remains constant over a wide range of resistivity, it reduces the stack emissions, it will consume less power, it maintains the spark rate, and it also eliminates back corona by not wasting the current that is used for charging. And the other is high frequency transformer rectifiers. This high frequency power supply for ESP is for rectifying and filtering the three-phase AC power to obtain the DC power, that is for modulating different working frequencies with very high modulation frequency. The principal components, operating principles, and the state of developing of new high frequency power supplies frequently called as switch mode power supplies. Moving to the operation of these switch mode power supplies, a 50 Hz three-phase AC input through full bridge rectification and then through insulated gate bipolar transistor inverter, it is converted to generate high frequency power supply, and then through high frequency transformer voltage boost, it finally get rectified into high frequency high voltage DC pulse power output. It has advantages like it can increase corona power from 3 to 10 times. Efficiency is increased from 20 to 60% than the last, and it operates a high frequency of 25 kilos to 35 kilohertz, and it can respond to spark in less than 40 microseconds. It is lesser weight and can handle high resistivity dust. It has lesser power consumption and a reasonable cost to be replaced. And the other is back filters. The efficiency of back filter was higher than ESP. These back filters separate dust from the exhaust gas by collecting them with the filter media. The dust that accumulated on the surface of filter media is cleaned by a reverse airflow called backwashing, and the cleaned air is sent out from the upper portion. It has advantages like low emission, it is of low cost, smaller size than ESP, it has high efficiency, and can it handle higher gas flow rate without limitation of size particle. Although it is having some disadvantages like it is not suitable for wet pollutants, higher pressure drop, and cannot handle surge in temperature for more than 250 degrees Celsius, and it is sensitive to corrosive gases. Though the pressure drop can be handled by using high capacity induced fans, and the temperature surge can be handled by heat exchangers, but this increases the overall cost of the project. So this back filter is not that suggestible. Moving to the conclusion part, in this case study, I have presented the use of ESPs at TSK. The principal operation of ESP is the factors that affect in the performance of ESPs, and about the three new technologies that I have come across to improve its performance. Comparing these three technologies, it was observed that changing the power supplies of ESP from switch mode power supplies to micropulse power supplies has half the dust emission level, and at the same time it also yielded to a reduction in power consumption. And this graph shows the increased efficiency for MPPS when compared to normal TR or switch mode power supplies. And as usually, there is also very increase in peak voltage level when compared to a normal TR and SMPS. And the results of installation of MPPS has shown that it is very cheaper, and it also required very shorter downtime than other power supplies. So this would be a better technology I would like to suggest, and it has shown very tremendous results from 2018, where there are 500 plants installed the MPPS till now all over the world. In general, the efficiency of ESP will vary from 85 to 98%, but usage of this micropulse power supply, the efficiency has been increased to a great extent of 99.8%, and it was seen in Xinjiang in China, which is a power plant, and it has shown the tremendous results, and it increased the efficiency to an approximate value of 99.7%. And with this, I thank Tata Steel for giving me this a wonderful opportunity, and I thank my mentor, Mr. Ashish Verma sir, for being with me till the end. Thank you, sir.
Well, thank you. Thank you so much, Sushma, for the presentation. That was quite insightful. And now let's see what our judges think about it. Very soon you'll know in the results.
Ma'am, I'm Surajit. Can I ask, take up the question?
Yes, sure, sir.
Yeah, Sushma, the very good presentation, very clear. I think
Thank you, sir.
at your level, you are able to explain almost all of this very clearly.
Thank you, sir.
Uh, I don't know whether you'll be knowing this, but when you go to the slide 6, where you talk about operating gas temperature, this is a technical stuff. It
Yes,
is
sir.
written as 76 degrees. So
$75.
is this temperature, if you know, is this the temperature at which you operate the ESP, or this is the cutoff temperature at
It
which
is a
you
cut-off temperature, like the temperature at inlet. Like temperature vary will be measured at inlet and outlet, and if the temperature difference is like if temperature difference is more than 75 to 100 degrees Celsius between an inlet and outlet, there will be an alarm introduced in ESP PLC, so that necessary actions like tripping of ID fans or tripping of TR panels will be taken. If not, the temperature rises to very high level, there will be a more amount of dust to be emitted into the outlet. So this is the inlet temperature of ESP.
Okay. So I'll tell you, this is the minimum temperature. At this temperature, we generally stop the ESP because of dew point. Probably it has been told to you.
Yes.
My one clarification is when you talk about process design parameters, the
Yes.
operating temperatures are in Fahrenheit. So generally we use centigrade. You're absolutely right where you see the drop in efficiency.
Yes,
Where
sir.
the temperature drops, the efficiency also drops.
Uh,
So you have basically based your presentations at Kalinganagar. So
Yes,
are
sir.
you aware
Actually,
what are yeah,
my mentor is from Kalinganagar, sir. So the information
okay,
which I got from him is from Kalinganagar steel plant.
okay.
Yes, sir.
So okay, no further questions. Thanks.
Thank you, sir.
Thank you.
Thank you so much, Mr. Sinha, for your questions.
Hi, good morning. Satish Tiwari this side, Sushma. Thanks for your presentation.
Thank you, sir.
I recommended two technology, Coromax technology and high frequency transformer rectifier.
Yes, sir.
So what can be done in the existing ESP to improve the efficiency or performance of the ESP?
Sir, this technology which I introduced, it has not been seen in India till now. But in many other developed countries like China, many of the plants were introduced with this technology.
That is okay. Sushma, my point is that what can be done in the existing setup to improve the efficiency or performance of the ESP? What are the problems? Why we are not able to achieve that desired level of ESP if there is any gap? And what can be done to take care of those gaps?
Sir, first thing is power supply. It should be a very high, like if there is a high voltage power supply, there will be less emissions. Like if there is less emissions, as usually more collection of dust take place, and efficiency of ESP will increase, and the stack emissions will be reduced to the required law. For this high voltage itself, generally we use normal conventional DC supply, but like there are 5 fields in each ESP. So introducing this Coromax technology in the last field of the ESP can increase its efficiency, because the gas from the ESP will be entering into the each field of ESP. So at the last field, if the dust entering at the last field, if it is having this technology, it is nothing but high voltage. So there will be a chance of high resistivity dust getting into the without getting into the outlet, it can be dumped into the hoppers. So that there will be less emissions into the outlet, and the collection efficiency increases. So there won't be any chance, and there it won't needed to introduce this technology in these 5 fields. It is enough if we introduce it in the last field, so that it will be economical, and also we can increase the efficiency. Yes, sir, this is my idea.
Okay, second question is how easy or difficult it is to use these technologies in the existing system? Have you studied that part?
Yes, sir. Yes, sir. So the first thing is power supply. Like as it is as it is applied in the roof of ESP, getting the power supply from the from the source of power to the field to the ESP is also major effect. As we need to get three phase supply. The power using the power cables and power supply, it is a major thing we need to take care of while supplying the power to, like using high voltage transformers. It is a major thing, but if we don't get required power supply to these transformers, it will be a major defect, sir.
And what is the cost implication related with this technology?
Yes, sir. Compared to other technologies which I have recommended, it is of low cost. Like it is not to the very low cost, but comparing with that, it is less than 5%. Like if the technology which I suggested, other is high frequency power supplies. Compared to this technology is having low cost, like to less than 8 to 9%.
Okay. I'm repeating my question. How easy or difficult it is to retrofit these technologies in our existing ESP at Kalinganagar?
Sir, it is the difficult part. As I know, it is the difficult part to retrofit the whole ESP, because as we are using normal convention, but taking into the other other technology, it may take some time, and it also required very longer shorter downtime for taking out the normal one and introducing the Coromax technology. But in my point of view, like we need to take care of all the factors like the power supplies, usages of the high voltage transformers, and but in my point of view, but to get the efficiency of ESP, it should be introduced, because increase the efficiency of ESP, but because the main aim is to reduce the stack emissions and also for greater efficiency, as nowadays the government is also trying for lesser emissions and environment. So however, it will be difficult to see all those introducing this retrofitting of these ESPs. But my suggestion is, it is better if we introduce it to increase its efficiency.
Okay. Last point. You discussed again and again about the issue related with the power supply. Do you found any problem with the our power system? Any gap or anything in that?
Sir, it mean like power supply. Yes, sir. Normally, if we use normal conventional DC supply, we can only apply give supply up to only 60 kilovolts, which is a normal supply voltage. But yeah, the ways to increase this voltage can increase the current provided and many other factors which increase the efficiency. But if we continue with this normal conventional DC supply, there won't be we can't increase the peak voltage. And these conventional DC supplies, voltage, current and frequency all are dependent. It means we cannot control them independently, but the technology which I suggested, in this voltage, frequency and current will be controlled independently. Like if actually if high voltage is supplied, there will be high current and there will be wastage of current. But by using these micropulse power supplies, we can achieve high peak voltage, but the current can be limited. Like current won't be wasted in the form of gas distribution, like charge distribution, and it will be used only for charging the dust particles. But these normal power supplies like normal TR sets will affect the efficient. We cannot increase the peak voltage to more than 60 kilovolts.
Okay. Thanks. Thanks. That's all from my side. Thank you.
Thank you, sir.
Hi, Sushma. Can you hear me?
Yes, sir.
So I think in a slide 6, you have mentioned about preferred range of resistivity. Okay, na, in micro.
Yes, sir.
So how do
Yes,
you
sir.
know that? Did you do any analysis? Or
Yes, sir. Actually, everything not experimentally, but the information I have mentioned here, it is everything I got from my mentor itself.
no, so that's okay. But did you understand that why that particular parameter is within the range?
Yes, sir. It is the preferred range for the operating of an ESP, and the ESP is designed to operate in such level. Like it is given by manufacturers as the resistivity range is 10 power 8 to 10 power 10 ohm centimeters, and if the resistivity is too high, there will be effects like there will be re-entrain or formation of back corona. It is the design ESP is designed for such value of resistivity.
So then the next point is, how do you control resistivity?
Sir, by not controlling resistivity, but we cannot emit like emission of high resistivity dust can be controlled. Like if there high resistivity, if there is high resistivity to the dust, there will be formation of back corona. By back corona, and the sparking takes place, for which the dust get emitted into outlet. But this can be controlled by giving high voltage supply to the ESP electrodes, and when high voltage is given, charging of that high resistivity does take place, and the emission back corona can be eliminated. By eliminating those back corona, the collection of dust will be taken into the hoppers without into a outlet.
So by controlling voltage, so just a minute. So by controlling voltage, you are controlling resistivity.
Not controlling resistivity, sir. Actually, I don't have idea about the controlling of resistivity.
Okay, no problem.
But
No problem. Carry on. So
yes,
second
sir.
point is, how do you increase and decrease gas flow? Because you also mentioned that increase in gas flow would also result into, higher efficiency of ESPs. So can you control gas flows in ESPs?
No, sir. It is also a designed value of ESPs. For these are designed parameters like gas flow. The parameters which I mentioned, like the gas flow, inlet temperature, these are designed for the per particular ESPs. And the one which I told is it is depends on us for choosing the ESP. Like if a gas volume is increased, it can increase the collection efficiency, and it depends on us to choose those ESP.
So you don't have any control. So whatever supplier gives, that you have to fine tune
Yes, sir.
parameters around that. That
Yes, sir.
is your view.
Yes, sir. The technology which I given is completely based on power supply to reduce the stack emissions of high resistivity dust.
Okay, so the last point for me is that with the Coromex technology, there are two advantages. One is obviously low level PM can be actually
Yes,
filtered
sir.
through, and you can get a clean gas.
Yes, sir.
And then the other point is, you talked about a reduction of power consumption. So how
Yes,
does
sir.
the technology help in terms of technological reasoning, not the supplier reasoning? How does it happen? Do you have any idea?
Yes, sir. Actually, when the low power consumption, it means nothing but we don't waste any current in any other ways other than charging. Generally, current is used for charging. But if this, if we supply more voltage and more voltage, there will be high current. If there is high current, when normal DR sets are used, current will be wasted and the dust will not be collected and it will be emitted. But when this technology is used, this technology eliminates back current. It is nothing but the charge which we got from the current which we got is used only for charging without using it for any other or without wasting. It means we are consuming the less power, like less current. So it less, as we are consuming less current, it would be lower consumption. And this, as we are using three-phase supply, it provides very high power factor. Very high power factor, nothing but it implies very high power, it gives very high power, and the current which we used is of low. It nothing but we are not wasting current in any other form other than charging the dust particulates. So in this way, I think it is. Yes, sir.
So now the existing ASPs to a Coromex technology, so you are actually utilizing more power for the gainful purpose. So that's
Yes,
what the
sir.
efficiency level is improving, or the power supply is constant, voltage level is increasing, current is increasing, and it is impacting the higher power factor, and so has less power consumption. Is it the right I would say conclusion?
No, sir, not in that way. Like we are giving high voltage, it's okay, but we are not wasting the current. Like if voltage is increased, as usually current will be increased. But introducing this Coromax technology, high voltage and current are independently controlled.
If the power is constant, why the voltage and current everything would increase?
Everything won't, sir, power is constant, voltage, current both will like if voltage is increased, current should be decreased. Then only power will be the constant one.
But so far you are referring to that voltage and current both will increase. That's what my point was. So if
General
the
case,
voltage increases, current will decrease, no? Current
yes,
cannot
sir.
increase.
Yes, it remains. If we don't waste the current, it means current will be in controllable way.
Okay. Thank you. Thanks.
Yes, sir.
Thanks, Sushma.
Thank you, sir.
Sushma, one last question, although it's an observation.
Yes, sir.
Yeah, in your first slide, you have the SPM of TSK sinter plant. What is the level now? The figure you are aware?
Yes, sir.
The SPM level, the process ESP SPM, which you have put a graph. What is the present level now? Are you aware of this value?
Sir, exact value I was not aware, sir.
Okay. Okay.
But I know the emission level, sir.
Yeah. Emission, stack emission.
Yes.
Any guess? What?
Yes, sir. It
Because-
should be less than or equal to 100 milligrams per normal meter
Hello,
cube. It
yeah.
is
Okay.
as my mentor, the same question I asked my mentor and he gave this answer for me.
Fair enough. Not an issue. Thank
Yes,
you.
sir. Thank you,
That
sir.
would be. Thank you.
Sushma, one question taking forward from what Mr. Majumdar had
ठीक
asked.
है और अगर सपोज हमारे पार्टिसिपेंट जल्दी खत्म
Bhavna, can you mute yourself, please?
Yeah.
Yes, sir.
Sushma, I'm taking one question
Yes, sir.
with what Mr. Mukherjee had asked just now.
Yes, sir.
Given one of the factor as gas velocity, flue gas velocity.
Yes, sir.
Have you heard of CFD or something like that analysis, or can we do anything with the gas velocity?
Yes, sir. It it means if gas velocity is if gas velocity is less, like for a preferred range of ESP, if gas velocity is less, more amount of dust will be collected. Like if the velocity is high,
How to improve upon the gas velocity? Any idea?
sir,
Or-
gas distribution screens are used, sir. GD screens. They evenly distribute the gas across the inlet of precipitator. When they evenly distribute collection, the distribution like area increases, and the emission from the inlet to the outlet will be in the controllable way. Like if velocity is too high, there will be more emission to the outlet. If velocity is in the preferable range, needed amount of collection will take place.
Okay. Okay, thanks. That's it. Thank you.
Thank you, sir.
Thank you so much. We would like to thank everybody here. Thank you so much to Sushma for this detailed presentation and our jury members. And one
Thank
more thing we request you to please keep in mind, we have 20 minutes for each participant. And we have almost 9-10 participants more joining us. So we request all of you to please limit your question to 5 to 7 minutes. Thank you. Thank you, Sushma.
Thank
So
you.
now let's move on, and we would like to invite our next participant, Shruti Kumari. Can we have you here, Shruti Kumari?
Ma'am, can I leave my meet?
Yes. So for Shruti Kumari, we have 20 minutes. So her session would end around 11:15, 11:10, 11, between 11:10 and 11:15. So please keep that in mind. Thank you so much. So we have Shruti Kumari here joining us. Sometimes there's some technical which is we request you to please have patience. Very soon she'll be here with us.
Ma'am, am I audible?
Yes, you are definitely audible. But we also want to see you.
But the sound is not coming from your side.
We aren't audible? Are we audible?
You are audible to us.
Yeah.
Shruti, are you there? I think she is logged off.
%50 of LPG cylinders in India are made from Tata Steel HR coil, and almost every model in automotive has some steel from Tata Steel. So, in between the virtual event, I'll keep on sharing some facts about Tata Steel with you all. Thank
Ma'am,
you so
I think
much.
there's some issue by my side. I can't hear your voice.
Shruti, you are audible to us. I don't know whether you are able to hear me. Seems some problem with that.
Clearly.
Yeah. All right. Thank you. Over to you. Thank you.
Ma'am, am I audible? And is my screen visible?
Yes.
Good morning, everyone. Myself Shruti Kumari from the IT Sindri, and I'm
Can you
pursuing my BTech.
can you be a little louder? Can you be a little louder, please?
Yes, ma'am. Good morning, everyone. Myself Shruti Kumari, and I'm from the IT Sindri, and I am in my fourth semester. And the title of my presentation was to identify the power reduction at ferroalloys, through the benchmarking and the global industry standing. So the first question that comes, why this project was necessity, is that as the ferroalloys of the iron have high percentage of one or more elements like silicon, manganese, etc., and they are brittle and unsuitable for direct use. So they need fabricating. So these ferroalloys act as an important raw material for the steel making process. And they are used in the deoxidation of the steel. They are used to prevent the corrosion of the steel for the industry. So these ferroalloys are usually classified in two groups, namely the bulk ones and the noble ferroalloys. The bulk ones include the ferrochrome, the ferrosilicon, and the noble ones include the ones that are used very less, like the ferrotitanium, ferroneodymium. Some of the alloys such as silicomanganese that contain iron are in very small percentage are also classified in the bulk ones. So the area of my project was on ferrochrome, on which the enablers have been identified, the analysis has been done, and recommendations have been proposed. From the data that I have analyzed, it is quite evident that the power cost mainly contributes 36% in the manufacturing process of the ferroalloy. So by reducing the consumption, savings can be generated, and the cost that is incurred against the power. Now, what are the major factors in the power consumption in ferroalloy process? The first and foremost one comes is the raw material. The input raw materials plays a very pivotal role in the power consumption during the ferroalloy process. The moisture content of the ferroalloy are the main contributors. But the control in this part is a bit difficult. As we know, the Tata Steel is a captive producer. So coming upon the next one, that is energy during the smelting. In ferroalloys, the oxides of the ore are reduced at very high temperatures to be converted into the alloys which require a large amount of heat. And this heat is provided through the electrical energy. So this can be controlled if we provide heat that is required to any alternate source so that the power consumption is reduced. Now looking upon the energy that is used in smelting. Approximately of 3,250 kilowatt hour per ton of ferrochrome production, this amount of energy is required in the ferrochrome production. The energy that is used in smelting can be lowered by taking some measures. Like the first one comes is the utilization of the off gases that are released during this process. These off gases are generated as a result of the reduction process that takes place in the furnace. So, and these carry heat which can be used for retrieving it from the gases, which can be used for the charge preheating process. So, this can be used in the heating of the charge so that less power is consumed. An alternate way to use this heat is to also use it in the power consumption,
Shruti,
the power
can you,
generation.
can you please make your presentation in the full screen mode?
Yes, ma'am.
Yeah, thank you.
Ma'am, is it done?
No, it's still.
Go to slideshow option and
Go
start.
to the slides option, yeah.
Yeah, the slideshow option. Yeah.
There at the bottom, you will find the slide slow icon, no? Notes, comments, and you will find some slides options. Yeah, the next one, and the next one. Yeah, this one.
So now is it visible clearly?
Yeah, very much. Thanks.
Thank you, sir. So, as I was saying, as this off gas can also alternatively be used in the heat generator, that in the power generation. So the next one that comes is to use the alternate fuel as hydrogen for electricity generation. The hydrogen can be used to generate electricity that can be used for the smelting process, but it won't be that much economically viable, and it would require a lot of facility addition and investment. Now coming upon the utilization of this gas during the manufacturing process. The most obvious source of energy that is coming out of the plants as an off gas is the CO-rich gas. So the substantial energy saving is possible using this gas. There are, however, some issues regarding the usage, as both the temperature and the CO content of the exhaust gas is varying from day to day, dependent upon the operation and the type of raw materials that are being used. So the temperature change takes place from about 100 to 800 degrees Celsius, and hence a recovery unit must take this into account. So the CO gas that the CO content may vary from 50 to 95% in the closed furnaces. The lowest possible CO content and the temperature obtained when the operation is going very well. So, however, the best energy situation is when the energy consumptions are very low, even though this correlates to the lowest energy recovery potential. But even when the furnace is operating at its best potential, there will be a lot of CO in the exhaust. And so here comes the recovery of the exhaust gases. As the study was conducted for ferrochrome manufacturing facility, I inferred that 37% of the total cost is contributed by power during the ferrochrome production. And 55% of the off gases is used after cleaning, and the remaining 45% is lost to the raw gas duct. Now, utilizing this through the charge preheating method. Presently, the closed submerged arc furnaces produce off gas which is partially used in plants for various heating purposes and partially being fed to the raw gas that are not cleaned. So the distribution is like that the total generated gas is 4,500 Newton cubic meter per hour. So the flared gas that is flared, not clean, is the 2,000 Newton meter cube per hour, and the gas that is clean is 2,500. And the composition of this gas includes maximum carbon monoxide that is 73%, carbon dioxide that is 5%, nitrogen that is 14%, oxygen and other gases 4%. And the temperature at which these off gases exit the furnace is about 750 to 800 degrees Celsius. Hence, these gases can be used for preheating purposes as they have that potential of energy. Now comes the concept of use of this excess gas. In order to utilize this excess gas containing carbon monoxide, obviously 73%, in ferrochrome making plant, technology is available for preheating of charge mixture for chrome, making in the submerged arc furnace. The process of heating of this charge mixture containing the chrome ore as its principal ingredient can use the energy in the furnace of the waste gas to preheat the mixture that is being fed in the furnace to the temperature of 500 to 600 degrees Celsius. And this preheater usually utilizes the energy that is present from the chemical energy contained in the clean gas as the energy source. The CO-rich gas is combusted in very specially designed chambers that ensures that the optimal air and fuel mixing is done and that controls the combustion of the gas at uniform hot gas of the mixture. Now looking upon the advantages of this preheating system. The reduction of the specific power to the tune is tuned to about 10 to 15%, and the moisture content and the volatiles that are present in the charge mixture that are fed in the furnace are also reduced. Then comes the stable operation. The furnace becomes more stable using the preheater system, and the available excess gas can be recycled and utilized as fuel within the plant. The chemical reactions existing in this preheating mixture is that the purpose of preheating is mainly to eliminate the moisture content that is present in the furnace feed that we feed in the submerged arc furnace and to calcinate and preheat the mixture to a very high temperature. The preheating is limited approximately to 550 to 600 degrees Celsius of the temperature, and the exothermic reaction that takes place through the conversion of CO to CO2 acts as the source of this preheater. Utilization through power generation. During smelting, this 4,500 amount of furnace of gas is produced that has a very high calorific value of 2,400 kilocalories per Newton meter cube. Only 2,500 Newton meter cube per hour of this gas is cleaned, while the rest 2,000 is released without clean and flared. Of the clean gas, only 2,000 is utilized and the rest 500 is flared. But there are some constraints to this utilization of the power in the power generation because it requires a facility addition, an increase in number of the auxiliary equipment inside the system for which synchronization of the plant of the power generation is very necessary, and this may create an issue. The recommendations that have been proposed through this project is in order to lower down the power consumption, some steps have to be taken. The first one is charge preheating of the raw materials that are being fed in the furnace for smelting purpose. The same methodology is being used at INFA and Tracer in India, the Samanker chrome and the Assaman chrome of South Africa and ferroalloy producers in Oman. Also for power generation, it is an option from the same gas. which is used in the charge preheating. And also it is a sustainable use as the energy can be regenerated rather than consuming the energy generated from fossil fuels. And it would rather also impact on the carbon footprint. So power generation and this type of power generation facility is also available in India with impact. So I would like to thank everyone for their patient hearing and like to thank my mentor, Sir Simanto Mazumdar, for mentoring me. Thank you.
Okay, Shruti, thank you. Can you hear me properly?
Yes, sir.
So, when you said, power can be produced obviously from off gas,
Yes, sir.
but if you, so you have been talking about a ferroalloy plant Bamnipal. What was the source for the information?
Yes, sir.
So this 37% and 73% of the concentration. These are plant
So it
specific
is upon
information
the
or this is theoretical information?
that there is a theoretical information that has been provided by the mentor. It has been studied that about 37% or 36 to 37% of the power, the cost is of the power consumption that is used in the ferroalloy plant.
No, so I think you didn't get me. I said that is it a plant specific information or is
Yes.
it a industry specific information?
So it is an industry specific information.
No, so that cannot be. Primarily reason is that while the consumption would be that, but power tariff is different. If the power tariff is different, then it cannot be 37%. You understand what I mean? Because power cost is tariff into consumption. Consumption would be 3250, but power tariff would be different. So if you look at the globe, the
Yes, sir.
tariffs are different from South Africa to India to Oman to Kazakh. So everywhere tariff is different. Okay, so I'm not just mentioning that 37% is a could be India specific information. I think
Yes, sir.
that's the
It
number
is,
one. Number
yes.
two, this 4,500 and 2,000, 2,500, is it a industry specific or plant specific?
So it would be plant specific information because it will differ globally.
No. So the point is that how much power can somebody generate if you generate some 4,500 meter cube CO gas? Any idea?
So how much power would be
Yeah.
generated? No, sir, I don't have idea.
Okay. And the other point for preheating of charge. So there are 2 points to it. One is once you preheat the charge, what does it happen actually? Why the power consumption will come down?
Like if we preheat as the mixture needs to be heated for the and fed into the furnace, if the charge or the mixture is preheated, then a less amount of energy would be required. Less amount of coke or the reductant would be required. As the off gases contain the heat, they would be heated to approximately of 500 to 600 degrees Celsius. So as the charge mixture goes into the furnace, a less amount of heat would be required to heat them. So that would
But
reduce the power consumption.
but that is nothing to do with the carbon. Huh? Carbon is required for the different purpose.
Reduction.
So why do you need less power? So listen to me carefully. Why do you need less power when you are preheating the charge to 500 or 600 degrees? What happens, in terms of energy requirement? Scientific explanation. Do you have any idea?
So like we need to heat the mixture. On heating the mixture, we'll obtain a molten mass that would be used in steel making. So like
So
if
what is the smelting temperature? What is the smelting temperature of so there are two processes happen in an electric
yes
arc
sir,
furnace. One
yes
is
sir,
smelting, other is melting. So
yes sir,
smelting, you consume power for smelting of the raw metal into alloys. Okay.
alloys, yes sir.
So you know what is the temperature required to smelt?
So it is about 800 to 900 degrees Celsius according to me.
No. So the temperature this requirement is about 1600 degrees centigrade. So the explanation is that if you had preheating the charge to 700
Yes,
degrees, so
yes sir.
because the difference in temperature from 1600 to 800 and 1600 to room temperature, energy requirement will be less. So that's the scientific explanation why do you need less power. Okay.
Yes sir.
Thank you, Shruti. That's all
Thank you
from
sir.
me.
So, Shruti, good morning.
Good
Sorry.
morning.
Just your project talks about benchmarking. So, what is the exact benchmark number you have taken? Ideally, what previous judge was trying to emphasize that even our plant there may be some numbers, and what is the benchmark number, and how do you bridge the gap? So I'm not able to see any benchmark specific numbers. Maybe it's there written in between. So since the project is big, the topic is beginning with benchmark numbers. So
Yes.
what is the benchmark number or a global benchmark number?
So I
You
didn't
want?
get.
Yeah.
I didn't-
So you are looking your project or the project is talking about say through benchmarking and global
Global
industry
industry
scanning.
scanning means comparing the industries.
Yeah, so you are comparing basically figures.
Yes,
So
sir.
what is the figure which is internationally available? So that is what I am looking for. So is this possible in our plant? I mean, what all things have to be done? I mean, that is what we were looking for. I mean,
Yes,
it's a
sir,
comment.
yes, so like we have to introduce a charge preheating system. Like
Okay.
first we have seen the advantages of the charge preheating system, that it has very
Okay.
much advantages, and it will reduce the power consumption. So we need to introduce a preheating system in the furnace process, so that the power consumption, that is the power that is consumed in the process, would be less.
So, not connected directly with your study. So, basically, CO2 generation, greenhouse gas, we talk a lot about.
Yes,
Is
sir.
did you try to study this aspect also? Because a lot of CO gas is generated through the off gas. So, I
Yes.
don't see it here, but as a suggestion, for future studies or when you take it forward, you can
So,
include it.
like, firstly, like if this preheating system is not available, these off gases would not be used. They would be released in the environment somehow.
Yes,
So it
yes,
would lead to a bad environment. So
yes.
using these off gases has two benefits. Firstly, the less amount of gas would be released in the atmosphere, and the secondly, we can use this as our power. So that would lead to a very efficient use of these preheating systems.
Okay. Thank you. That would be all
Thank
from
you.
my side. Thank you.
Shruti, good morning. Satish Tiwari this side.
Good morning, sir.
I have one thing to say that this is a good idea to use the energy sources which are being generated through the process to
Yes, sir.
improve our efficiency and power saving. So what Mr. Surjit wanted to know, and I will also like to know that you mentioned that 37% cost is because of power. That is 37%.
36 to 37%.
What should be the theoretical power consumption for this type of operation? कितना होना चाहिए था? Is it okay, 36%, or should it have been 25% or what? I don't know. So what was your study?
So like we need to produce a very economical ferroalloy at the end.
Mhm.
So
Mhm.
the amount of power that has to be used should be less. Should take
So
less
that is okay.
percentage of it.
That is okay. So there must be some calculation which will indicate that for given this type of operation, how
Yes,
much
sir.
power is required, considering the raw material quality, whatever is available with us. So what was that percentage?
So that exact percentage I'm not
Okay.
sure.
Okay. No issue. Second question is that you
Yes, sir.
said to reuse the off furnace gases, which is at 800 degrees centigrade and having good calorific value. And
Yes,
this can help in reducing the power consumption by 10 to 15%. That's a
yes,
huge saving. So
yes.
what is the difficulty in using this technology? Because in general, in steel plant, we try to utilize this type of energy resources. So
Yes.
what is the constraints at a ferroalloy plant, because we all understand that if you add any facility, it will have some some
Disadvantage.
additional equipments and all, not disadvantage, some equipment.
Okay.
But considering the 10 to 15% power saving, why this idea has not been implemented? What was the constraints? What are the thought of the plant people?
So some of the constraints that would have come in the application of this into the ferroalloy plant is that firstly the CO content. The CO content varies a lot. It depends on the amount of raw material that is being used in day-to-day production process. So this would lead to a very uneven production of the off gases. So we can't fully rely on it because sometimes the percentage of CO that is released would be 20%, 25%. Sometimes it would be 35 to 50%. So we could not fully
Still, so
rely on this.
Shruti, still we will have some advantage. When the gas quality is good, then we will have the benefit. When the gas quality is not good, we will not have the advantage. But overall, from
Yes.
not using to using something, that is always better.
Yes.
So why it is not being used? What are the constraints? What are the technical
So
constraints?
maybe the technical constraint that would have come in using these would be that it requires a lot of installation and the installation process of this would be tough. So it is not that much introduced into the ferroalloy plant. Maintenance of this into the ferroalloy plant of this preheater systems would have been difficult.
Why you think so?
So because this is a preheating system, so it would require a lot of instruments or the equipment that has to be introduced. And maybe the new system would not be handled that much well, so it would be not introduced in the ferroalloy plant. Or maybe the idea is not yet come up.
Okay. Thanks. That's all from me.
This is Anurag. So taking the questions further. So you are telling a lot of equipments are required. So what type of equipments? What these equipments are supposed to do?
So maybe specific equipment.
Yes, you are telling it needs lot of equipments.
Yes,
What
like
comes to your mind?
it is
These
a system,
what
so it
these
would
equipment will
include a
do?
lot of.
Hmm?
So like it is a system, so it would include a lot of instruments, like the pipes would be introduced for the gas to pass into the furnace.
No, pipes is of course. What these equipment? Let us say I am using the word one system is required having lot of equipment. So what the system is being envisaged? What comes to your mind? Because gas-based power plants are 50 years old, maybe more than that, 70 years old. Then why it could not be done in ferroalloy? That is the question. What is the difficulty? If you say a lot of equipment, then what type of equipment? What you need? What you want to do with this gas? And now I'm changing the question. What is the difference between this gas and the natural gas, which is available by Gas Authority of India Limited, or let us say cooking gas? Both are gases. Both have calorific value.
Yes, sir.
So what is the difficulty in this?
So both gases can be used, but if we use this gas that has not been used and it is being fed into the environment. So if we use this gas, then this would be more effective rather than using the
Right.
gases from outside source.
That's right. But why it could not be done in entire ferroalloy industry? Okay, please think on this issue. Compare the quality of natural gas and the gas which is coming out in ferroalloy business or in a steel plant is different. It poses a different kind of challenge. Although calorific value is there, but
Yes.
there are issues. Huh? Okay, good.
Thank you. Thank you so much, Shruti, for your quite an insightful presentation. I would also like to thank our jury members. Well, now our next participant is Smriti Sinha. And Smriti Sinha has 20 minutes. So her time would get over at 11:45. Thank you so much. So we request everyone to please keep the time frame in mind, as we have a lot more participants coming here and presenting their innovations. So can we have Smriti Sinha here, please? Okay, so we have Smriti Sinha here with us. Smriti, you can begin with your presentation.
Yes, ma'am. Just a second. Am I visible? Audible?
Yes, Smriti, you are you're audible, but you aren't visible.
Yeah.
Yeah. Hi. Welcome, Smriti. Yeah, you can begin with the presentation. And you have 15 minutes, and 5 minutes is the interaction that we have with the GP members. Best of luck. Thank you.
Is visible?
Yeah, it's visible, but it's
It's
not
visible.
clear.
Right?
It's little hazy.
Maybe it's
You can see
connectivity.
your internet connection.
Okay. If I can I start? May I start?
I think you can, yeah, because we can't see you. Yeah, there's no clarity in your video. Can you just check your Wi-Fi, please?
Now.
Yeah, it's better. It's better. Thank you.
Good morning, respected panelists. My name is Samriddhi Sinha, and I'm studying Bachelor of I'm pursuing my Bachelor of Technology in Environmental Engineering from IIT ISM Dhanbad. And today I'm going to present my project title to find out the impact on carbon dioxide emissions due to the replacement of conventional trucks with the electrical trucks inside the plant. So as we know, the greenhouse gases are responsible for keeping the Earth's temperature stable and warm. But due to the recent human indiscriminate emissions of greenhouse gases such as carbon dioxide, it has led to global warming, which is leading to climate change, which is identified as one of the major global risks. The other problem with carbon dioxide is that it stays in the atmosphere for centuries as compared to the other more potent greenhouse gases, such as methane, which stays just for a couple of decades. So there are various commitments done to reduce the carbon dioxide emissions at the various levels. For example, at the international level, the Paris Agreement, which is a legally binding international treaty on climate change, has been adopted by 196 parties at COP21, whose goal is to limit the global warming below 1.5 degrees Celsius as compared to the pre-industrial levels by 2100. At national level, at COP26, Indian Prime Minister Shri Narendra Modi declared a 5-fold strategy to demonstrate India's commitment to achieve net zero emissions by 2070, which was termed as Panchamrit. At Tata Steel plant level, the carbon dioxide.
Your slides are not changing.
Is it changed now?
Not it.
No. Yes.
Yeah. Please get.
It's changed, right? Okay. So at the Tata Steel plant level, carbon dioxide, which is one of the critical material issue for Tata Steel, has targeted to attain reduction of carbon emissions by 30,000 per ton of crude steel by 2030. My project was conducted at Tata Steel Meramandali in a virtual mode. A little bit about the background of the location. Tata Steel Meramandali, which is TSM, is an integrated steel plant of 5.6 million ton per annum capacity, which is located in village Meramandali in district of Dhankanal of Odisha. TSM has taken initiatives to reduce scope 3 emissions, which I'm going to talk about in the next slide, by introducing electrical vehicles and increase in the transportation of raw materials and products through rail and sea modes. TSM has deployed medium and heavy commercial vehicles, that is MHCVs, through vendor partners. That means it is not owned by the organization. So there are three types of emissions that we are concerned about: Scope 1, Scope 2, and Scope 3 emissions. Scope 1 emissions are direct emissions from the sources that are owned or controlled by the company. Scope 2 emissions are indirect greenhouse gases emissions associated with the organization's energy use, that is due to the consumption of purchased electricity, steam, heat, and cooling. And Scope 3 emissions are also indirect emissions as a result of activities from the assets not owned and controlled by the company or the reporting organization, and it includes all the sources that are not listed under the Scope 1 and Scope 2 of the organization. So again, the title is to find out the impact on carbon dioxide emissions due to the replacement of conventional trucks with the electrical trucks inside the plant. So a little brief about the title. So there are different types of vehicles that run in the plants, namely high-bar, trailer, trucks, etc., of different capacities and purposes, which comes under Class 8 vehicles. These are diesel-run vehicles and contribute heavily in the emission of carbon dioxide in the atmosphere. So the plant aims at converting all the diesel-run vehicles into electrical vehicles in a strategic manner. However, there is a point to note that though the electrical vehicles do not produce carbon dioxide in a direct way, but the sources of production of electricity may produce carbon dioxide. For example, if the source of electricity to charge the electrical batteries of electrical vehicles is coal-based power plant, it will result in the emission of carbon dioxide in a larger picture. So in methodology, to study the impact on carbon dioxide emission, to study the impact of replacement, I primarily calculated the amount of carbon dioxide emissions from different departments using different sources of energy. For example, for conventional trucks, I have calculated the amount of carbon dioxide by the consumption of diesel. And for the electrical trucks, different options have been made consisting of different ratios of sources of electricity, that is grid, which is coal-based, and renewable energy here is being considered as solar power electricity. Option 1 consists of only grid, and option 5 consists of electrical sources 100% renewable, that is solar power electricity, and option 2, 3, 4, and 5 show different proportions of grid and renewable energy source. A point to note here is that we are considering a proposed project of installation of 7 megawatt floating solar power plant, which is going to be built inside the plant itself. And the project has already been started and is expected to function from the next financial year. In the calculation, to calculate the amount of carbon dioxide produced by the diesel vehicle, I have used the following formula. That is total diesel consumed per year into the emission factor. As per the definition, an emission factor is a representative value that attempts to relate the quantity of pollutant released with an activity associated with the release of that pollutant. And the total diesel consumed per year was calculated by collecting different data from the department itself, such as number of vehicles employed, average distance covered by each vehicle per day, and mileage of the particular vehicle. For electrical vehicle, I have calculated using a similar formula, that is battery mileage into emission factor into total truck movement per year. Here, the emission factor relates to the amount of carbon dioxide that will be produced due to the consumption of coal to produce 1 kilowatt hour of energy. Total truck movement has already been told, as in how it will be calculated, and battery mileage is already given for a particular vehicle. A point to note here is that this shows the amount of carbon dioxide generated when using electricity by only grid. So for example, if we want to see about option 2, which is 75% grid and 25% renewable, we'll multiply the same value with 0.75. As a result, we found out that there are 60 vehicles that have been deployed in TSM for material and solid waste handling across 8 departments, which is responsible for about 2,800 ton of carbon dioxide production per year. So there were two observations made here. First, on the left-hand side, as we can see, as we use more of renewable energy sources, the carbon dioxide emissions decreases. And secondly, on the right-hand side, we can see for the option one, that is 100% grid electricity source, the carbon dioxide saving is negative. That means the amount of carbon dioxide produced by the electrical vehicles used under option one will produce even more carbon dioxide as compared to diesel run vehicles. Hence, it is imperative that we use renewable energy, clean renewable energy sources as well with the electrical vehicles. This is a similar graph as shown in the previous slide, only this also shows different departments together in the graph. That is carbon dioxide emissions versus different options that were available. And this is a pie chart showing the amount of carbon dioxide produced by diesel and MHCVs by different departments. Here we can see DRI, which is direct reduced iron plant, is responsible for about half of the emissions, followed by CMP, that is central maintenance plant, which is responsible for about 60%. And sinter plant 1, 2, and 3 are least responsible. So we see that the the employing of electrical vehicles will be beneficial to be used under option 2, 3, 4, and 5. But how do we do it? So we need to develop a phasing out model, for which I have calculated three types of data. That is firstly, the input cost or the capital cost that will be invested to purchase electrical vehicles. As in the present market, there is no different varieties of electrical MHCVs that is available. Hence, we took help of a study by Claire Bees of ICCT, which assumes that building a corresponding electrical vehicle will cost about 2 to 3 times than its diesel counterpart. In the second step, I have calculated the cost of running per kilometer by diesel vehicle versus cost of running per kilometer by electrical vehicle. And I found out that the savings per unit distance, there is a savings per unit distance done if we employ electrical vehicle. Thirdly, I calculated return of investment that was calculated using the following formula, that is input cost upon savings per unit distance into total distance traveled. ROI denotes the time after which the capital cost will be returned to the organization itself due to the savings done per unit distance done. So ROI with other relevant data was tabulated along in the following table. And we found out that the DRI, which is responsible for about half of the emissions, takes the least ROI. So as a conclusion and recommendation, I have 5 conclusions. That is option 2, 3, 4, and 5 are feasible options, out of which option number 5 is most beneficial one, particularly because it will help in net zero emissions. And secondly, the cost of renewable energy, that is solar power electricity, is cheaper than the grid-based electricity, wherein solar power electricity costs about rupees 6.4 and grid power electricity costs about rupees 8.74 per kilowatt hour of energy. Secondly, there is a saving of rupees 24.5 per kilometer in running electrical vehicles as compared to the diesel vehicles. Third, there is a strong point that there is already a proposed 7 megawatts floating solar power plant that is being considered as a viable renewable electricity source for charging the batteries of electric vehicles. Fourth, again, quoting a study done by Claire Bees of ICCT, wherein it is mentioned that it takes about 15% cheaper to maintain a electrical vehicle than its diesel counterpart in terms of fuel and maintenance. Then fifth, I calculated the cost of abatement of CO2 for a particular department for an example, and we found that as the year goes on, the cost of carbon dioxide abatement decreases. And after the period of ROI, it actually does not cost abate any carbon dioxide. So, as a recommendation, using the data and figures and the calculation, it is saying that the phasing model can be developed in a phase, that is, the electrical vehicles can be phased in a phased manner, department-wise. And since the DRI is responsible for about half of the emissions and ROI is least for the same, it will be beneficial to phase out the vehicles from the DRI first, which will also serve as a faultless pilot study to analyze the effect of phasing out of vehicles. There were 4 alternatives also explored. along with the study. Firstly, conversion of diesel MHCVs to electric MHCVs, that is retrofitting. The input cost is very high, and and it's very less efficient method. Optimization of vehicle routes. Again, it cannot be done because the vehicle route has already been planned in accordance to the shortest possible route. And still, if any optimization could be done, it cannot be a permanent solution. Laying down of conveyor belt. Laying down of conveyor belt will not be easy because it is not feasible, because waste is being collected and transported from one different point to the other different point. What ethanol blending could be employed is in an altogether new study wherein various aspects needs to be explored, such as carbon emissions in producing ethyl alcohol, availability of sources, blending processes, and effect on emissions of carbon dioxide produced by vehicles on its consumption. The only problems with this alternative is it will only help in the reduction of carbon dioxide but cannot achieve net zero. This will be my end of project. I would like to say that the employing of electrical vehicles is just not environment friendly, but also budget friendly also. Hence, it will be beneficial to use electrical vehicles. And in the end, I would like to thank Tata Steel for providing me this opportunity. And I would like to extend my gratitude for my mentors who helped me throughout the study. Thank you.
Samriddhi, this is Anurag.
Yes, sir.
So this solar power capacity 7 megawatt. Is it peak or average?
Sir, it's peak, I think. It's peak 7 megawatt.
So when it is peak, then the average power available will be how much?
Sir, I'm not aware about it, but I have calculated in an altogether in my study that it will be actually it will be enough to employ for the electrical vehicles as well as other consumption also.
Yes, since you do not know, it is only 20%, maximum 25% for this. So the 7 megawatt which you are considering is probably 2.5, and that too it will be available only during daytime. So this is one aspect which you should consider. The solar power plants ratings are in peak, and average is normally 20 to 25%, depending upon in which area you are. Second thing is the main purpose. The purpose is to reduce CO2 emission. That is the main task, na? Because you started the national targets and the Tata Steel targets. So why I should go convert my vehicles to EV, put investment, install charging stations? The best thing will be whatever solar is generated, I will reduce carbon intake, let's say coal intake in my power plant, and CO2 reduction is directly achieved without doing anything. Just connect it with the grid, reduce the coal power based generation. Simplest thing. This should be done first.
Sir, since we are in that case, we are producing carbon dioxide emission at 2 points at the power plant also and at the vehicle level also. So here I'm trying to say that we are reducing, we are doing the net zero at the vehicle level also, and we are doing the net zero at the power plant also. So this is the maximum carbon dioxide abatement that we can do.
And you are not, in your option, you are not doing reducing at power plant, because 7 megawatt or whatever 2.2 megawatt you are using not for the compensating the coal power waste generation, but you are using for the charging of the electric vehicle. So it cannot be utilized at two places. Okay. Thank you.
Thank you, sir.
Smriti, good morning. Satish Tiwari this side.
Good morning, sir.
If you come to slide number 12, where you have mentioned that the saving is 24.5 rupees per kilometer.
Yes, sir.
If we are using the electric run vehicles compared to diesel vehicles. So
Yes,
this diesel driven vehicles, what is the mileage they give generally? And how this
Sir,
could be 4.5 rupees per kilometer savings has been achieved?
Yes, sir. Can I change it to another slide? I can show it. I have done it in extra. So this is the annexure where I've put how I've done this. I have calculated the cost of running per kilometer by diesel vehicle, and the formula is also written here, and as in how I've calculated cost of running per kilometer, and similarly for the electrical vehicle also. And this is how I've calculated the savings.
Okay. Okay. Fine. My another question is, what are the challenges with the electric vehicles in the present scenario, or whatever the technologies are available with us?
So the main problem is first the capital cost. The capital cost is a lot, is actually a lot. And the
So
second problem,
capital cost due to what?
capital cost of the electrical vehicles are very high because it is a new technology. It's right now not in the industry in the Indian market. And secondly, the disposal of batteries.
No, before disposal of batteries, this high capital cost is due to which component of the or which part of the electrical vehicle?
Sir, I think it's because of the battery.
Because of the battery. Okay. Thanks. That's all.
Okay, sir. Okay, thank you, sir.
Any more questions?
Oh, nothing from me. Thank you.
No, it's okay from me. Thank you.
Thank you, sir.
Thank you, Smriti. That was quite an environment-friendly presentation. Thank you so much for sharing that with us. And yeah, now we'll call our next participant, Chaya. Can we have you, Chaya, here? Thank you so much, Smriti. You can exit this meeting.
Okay.
So now we have Chaya with us. By 12:10, we'll move on to our next participant. So we have approximately 20-25 minutes with this participant. Can we have Chaya, please? Thank you.
Good morning, ma'am.
Good morning. Hi, Chaya. How are you?
I'm fine, ma'am.
Thank you. Thank you so much. So you're audible. Your voice is also audible. Best of luck for presentation. We have a jury member here.
Ma'am, may I start?
Yes. Thank you.
So, good morning, everyone. My name is Chaya, and I'm from IIT ISM Dhanbad. The topic of my presentation is optimization of specific diesel consumption in HEML in Jodai's iron mine under the guidance of Mr. Brasbinod Kumar sir and Mr. Devadatta Dey sir. The slide is not changing. Give me 1 second. Yeah. So objectives of the project. So in this project, we'll see the diesel consumption in HEML and factors affecting it. And at the end, I'll suggest some measures for its optimization. Let's have a look on project plan. So we'll start with the introduction and then go for need for study. Then factors affecting diesel consumption in HEML. Then analysis for the same. Then recommendations and at last references. So starting with the introduction, let's see what is HEML. HEML stands for Heavy Earth Moving Machinery, used in open cast mines for activities like drilling, excavating, loading, transporting, etc. Here are some examples of HEML: shovel, dumper, drill, grader. Now, what is a specific diesel consumption? So, it is the amount of diesel consumed by a machine
per run hour or per metric ton. So it is now clear that the project is all about optimization of diesel consumption per run hour for open cast mining machineries which are operating in geodized iron mine. Need for study. Why is it required to optimize diesel consumption? Here are some factors like increasing cost of diesel, its environmental effects, and sustainability. Diesel combustion causes greenhouse gas emission, which has its impact on changing global climatic condition. So reduction in diesel consumption obviously reduces greenhouse emission of gases. And here we have the approximate cost distribution of some main mining activities in open cast mines. And it is showing that around 60% of the total cost goes in hauling. And here diesel constitutes 40 to 50% of total operating cost. So reduction in diesel consumption obviously reduces the total mining cost per ton. Here is the chart showing variation of diesel prices. So from this chart, we can see that the diesel price is very unpredictable about its rise and fall. So this is why we should consider it as one of the factors. Now, as we all know that HEMM covers a large variety of machineries. Here I have considered some of them which are operating in geodized iron mine, and this Pareto chart is showing dumper, loading unit, drill as vital few because these machineries have more impact on diesel consumption. So we'll consider only these three machineries for our fuel consumption analysis. Now, let us see what are the various factors that affect fuel consumption in HEMM. First one is operator speed. So overspeeding should be avoided from the perspective of safety and also fuel consumption. Route, shorter the route, lesser will be the fuel consumption. Braking. Whenever the operator applies brakes aggressively or hardly, then the transmission suddenly shifts to lower gears, which require more RPM and increases fuel consumption. Gear selection. So fuel consumption depends on how the operator is changing gear in different situations. It also depends on road design, function, traffic conditions, which are also parts of mine plan. So road layout, road design and its maintenance obviously plays an important role in fuel savings. Traffic management, if not managed properly, then it can increase total traveling time or can say working idle time. Production, so higher the production target, higher will be the fuel consumption. Vehicle characteristics, tires. So proper maintenance of tire and tire pressure should be there because underinflated tires can cause wear and tear on tires, higher rolling resistance, and also tire blowouts happen while driving. Aerodynamics, so it is the aerodynamic drag which opposes the motion. So lesser the aerodynamic, lesser will be the fuel consumption. Weight or can say payload, lesser the payload, lesser will be fuel used. Engine, so effective working of engine eliminates the excess fuel consumption. Haul road, rolling resistance. So it is the friction offered to the tires when it rolls. So lesser the rolling resistance, lesser will be fuel consumption. Quality. According to a journal, a good quality of haul road can save up to 30% of the fuel. Grade. Higher the gradient, higher will be fuel consumption because with increasing gradient, work done against gravity also increases. Environmental conditions. So weather. In colder climates, it takes more time for an engine to reach its maximum fuel efficiency capacity. So there is fuel loss due to extra time, and also in rainy or foggy days, it creates visibility problem. So the operator drives too slowly, which increases the fuel consumption. Fleet management, so tire maintenance. Tire management, tire pressure should be properly maintained because 1 bar deviation from nominal inflation pressure can increase rolling resistance by 5%. Fuel management, controlling and monitoring of fuel consumption can make it used efficiently. Driver management, aggressive driving can waste fuel and can create needless wear and tear on vehicle. So managing fleet drivers ensure their safety and also fuel consumption. Truck maintenance, a well-maintained truck operates at maximum efficiency. Let us see what are the various factors that affect diesel consumption in drill. So these are compressor, loader engine, throttle gear control, operator, and RPM of engine. And here are some functions that can be optimized to reduce fuel consumption. These are drill hole flushing, dust collection, dust wind. For example, in case of drill hole flushing, it is normally done at maximum airspeed. But maximum airspeed is not required all the time. If we adjust the pressure, we can save fuel there. And the operator can save fuel as much as by 20%. Here is the fuel consumption analysis in liter per hour. And here is the table showing average data of 3 months, April, May, and June 2022 from geodized iron mine. This chart is showing that drill D659 has consumed maximum fuel per hour and drill D667 has consumed minimum fuel per hour. Let us see what are the various factors in case of soil. So these are operator practices, how much experienced our operator is, its habits and attitude also affect diesel consumption, operating conditions like mine conditions and its interactions with dumper, engine. So technology and age of engine obviously affects the fuel efficiency, loading time. So it depends on shovel loading rate, nature of blasted material. So more the loading time, more will be fuel consumption. Digging trajectory. So precise tracking of digging trajectory avoids the inefficient use of fuel. Let us see analysis of diesel consumption in shovel. Here is the chart showing operator performance on the basis of ton per liter, and the operators with low performance should be trained, and that with high performance should be awarded. Here is the fuel consumption analysis in liter per hour and liter per ton. So it is showing that the shovel E569 has consumed maximum fuel in terms of liter per hour and liter per ton both. If we exclude the loaders, then E564 has consumed minimum fuel in terms of liter per hour, and E584 has consumed minimum fuel in terms of liter per ton. If we talk about loaders, then W2K006 is consuming minimum fuel, that is 0.136 liter per ton. Here we can see that E569, 564 and 584 are showing maximum and minimum fuel consumption. So let us compare these three shovels. From this chart, we can say that E584 is working efficiently with material handling of 497.11 ton per hour. And if we talk about E564 and 569, then in 1 hour, E569 has consumed 20.2 liter more fuel than that of E564, but it has also handled the material 59.6 ton is more than E564. From this analysis, we can say that the fuel consumption for different shovels are not same because of different operators' skills, amount of material handled, number of trips, and different run hour. Let us see what are the various factors that affect diesel consumption in dumper. First one is payload. So more the payload, more will be the fuel consumption. Idle time. In case of working idle time, when the engine is left on but the dumper is doing nothing, there is fuel loss. Haul road. It should be maintained so that it offers minimum rolling resistance. Tire wear. If not maintained, then it can cause more wear and tear of tires and increases fuel consumption. Lead distance. Lesser the lead distance, lesser will be fuel consumption. Rolling resistance, higher the rolling resistance, higher will be the fuel consumption. Let us see some other things like aerodynamic drag. So around half of the fuel goes in reducing this aerodynamic drag. Tire inflation, so underinflated tires by 10% increases rolling resistance by 20%. Fluid management system. So for lesser fuel consumption, it is required to optimize fluids time to time. It also ensures end-to-end monitoring of production and improve safety. Let us see impact of operators' behavior on fuel consumption. So it can save 20 to 30% of the fuel. Speed and braking are the things that depends on operator's choice. Here is the analysis of operator performance on the basis of efficiency, and operators with low performance should be trained, and that with high performance should be awarded, as Sabasi scheme is already there. And here is the analysis of diesel consumption in dumper in liter per hour and liter per ton. And dumper 42 and 18 are showing considerable variations from FMS data. And if we talk about fuel consumption, then in terms of liter per hour, 22 and dumper 42, 22 is consumed maximum fuel and 42 has consumed minimum fuel. And if we talk about fuel consumption per tonnage of material hauling, then dumper 21 and 43 have consumed least fuel, and dumper 18 and 19 have consumed most fuel. These variations are due to different operators' skill, run hour, different amount of material, and number of trips. Here is the chart showing month-wise average waiting time per trip at dump plant, and this time can further be reduced to optimize diesel consumption. Let us see recommendations. So in case of Sovel, it is a double-sided loading. It reduces the waiting time of the dumper. Precise tracking of digging trajectory. If not precisely tracked, then the shovel would have to dig twice or thrice what it could do in one go with precise tracking. Third one is dumper and shovel pass matching and optimizing the position of shovel in relation to dumper. Operator practices. If the operator is not showing proper skills, then it should be trained to strengthen its skills, awareness, judgment, and knowledge. Material diggability. Suppose we have dry fines, then we can change its diggable properties by using water. It will cause ease in material handling. In case of drill, compressor control. So increasing compressor pressure level only when it is required. RPM control of engine, RPM should be set as per the requirements because higher RPM also cause higher vibrations and low drill bit life.
Audible? So is it for me or no?
Not audible to me also.
Not audible. I think she's got disconnected probably.
So we'll just wait for 1 or 2 minutes and then we'll move on with the next presenter. If she doesn't join us, then we can have her later maybe.
Better to ask her to rejoin, because maintain the continuity.
So I think we should move on with our next participant. Or I'm waiting for our technical team to connect with her and she can join us again.
I think we need to finish her fast because otherwise, it will be a disconnect.
Yeah.
Because almost
Yeah.
she's
We just getting in touch with our technical team.
She's at the last slide, I believe. So
Yeah.
Yeah. So can we have Chaya again, please, here? Yeah. So we've contacted her again. She's joining us. Just few more minutes. She'll be here with us. you so much for cooperating with us. Can we have Chaya here, please? I would request Mr. Mukherjee also to please join us. Can we have you, sir? Yeah, hi, sir. Welcome. Welcome once again to all the jury members. Chaya, so there was a technical glitch. We want you to proceed with from where you left us. Thank you. Chaya, you can begin with your presentation. Chaya? Can you hear us? Chaya, you can begin with your presentation.
These are the challenges of virtual platform. Okay. I don't know. 10 candidates who should have actually had it in person. I don't know why they have organized now.
She joined us. I don't know what happened. She just joined us. Sir, can we move to the next participant? I mean, it depends upon a jury.
I think now we have to, otherwise we are wasting time. Yeah.
Yes, I think we should
That's my
move to
views.
last participant.
Yeah, okay. So the next participant we have with us is Anjali Tiwari. Can we have Anjali Tiwari here, please? Anjali Tiwari. Yeah, so Anjali Tiwari is here with us. She's joined us.
Good morning, ma'am. I hope I'm visible and
Yes,
audible.
yes, you are visible. Yeah. You can quickly go on with your presentation. Anjali, please keep
Yes.
in mind you have 15 minutes and 5 minutes for the Q&A. So
Yes,
the
ma'am.
session would get over at 12:30. Thank you. Best of luck.
Thank you, ma'am. So thank you for, first of all, I want to thank Tata Steel for giving me this wonderful opportunity to present my idea in front of everyone. Good afternoon, everyone. This is Anjali Tiwari. I'm a BTech student of Raipur, and the problem statement which is given to me for today's presentation is optimize HMM excavator and real dumpers productivity through lead monitoring. And I had prepared this project under the guidance of Mr. Ravi Ranjan Singh sir. So let us begin with our project. So First of all, let's see what are the key points of my project. So my project contains understanding of existing technologies for lead monitoring, then analyzing the technical gaps in our existing technology, then conceptualization of better technology. Then we will understand that establishing operational benchmarks in our lead monitoring with HMM productivity, and then AI-based lead monitoring OITDS is the ultimate solution of our problem. So let us start with our introductory part. So as we know that 90% production in India comes from open cast, and in my point of view, in upcoming 10 to 15 years, open cast mining will be Indian mining's future. So if we want to increase our production with the help of open cast mine, HMM is the most important part because we use heavy earth moving machinery for our open cast mining, and HMM is the therefore most important and most successful event for our open cast mining. Then, as we know that economy is equal to high productivity. If we want to increase our country's economy with the help of mining, then we have to increase our productivity. And increasing productivity is possible only a great lead monitoring system. And therefore, lead monitoring system is the only solution for my problem. So, first of all, let's see what kind of mining operation with the help of HEMM open cast mine we perform. First is space preparation, then drilling, then blasting, then shoveling, then trucking, and then dumping. So these are basic operations we perform with the help of HEMM. Then I had given a formula for production capacity of HEMM is equal to bucket capacity into swell factor into fill factor into machine travel and positioning factor into 3600 into 8760 divided by average cycle. So let us first understand what is lead monitoring. So lead monitoring is basically analyzing the condition of haul road, gradient of haul road, lead distance, depth of our open cast mine, and many other open cast mine factor to set a benchmark for our HMM operation. Let's see what are the techno-economic benefits of lead monitoring. First, it will provide a system for performance analysis of mine, then lead distance management, then precise trucking, arrival time, and arrival time prediction, implement blending of any dump based on assigned material qualities and digging location, and it provides an adjustable shovel coverage. It adjusts shovel feeds to match available truck feed. In executable instruction, it detects a misroute and create a misroute warning. Then it integrates shovel priorities and material priorities. Then it helps to determine the availability of heavy earth moving machinery. Then it detects intermediate call point arrival as the point in which truck moves from one road segment to another road segment. And then all road gradient management is possible with the help of lead monitoring. So let's see what kinds of factors affect productivity of etching because our major concern is productivity. So these are basically four factors: equipment, operator, nature of plastic material, and operating condition of mine. These are four basic factors which affect productivity of any open cast mine and HPM. So in equipment, we can see that cycle time, tonnage handle, and health are the basic factors. Operator skill and behavior is important for productivity calculation. Presence of bulldozer and toe formation in the field of nature of blasted material is important. And operating condition of mines, there are many factors that affect the productivity of HMM like lead distance, blind spot, less road width, phase width, and haul road condition. So basically, these are key factors which affect productivity of HMM. Now let us discuss that how we perform lead monitoring by GPS. In Tata Steel, Jokaro, and Joda East Iron Mine also implement this GPS-based lead monitoring system. Before knowing that, let us see what are the operational cycle of open cast mine. So, operation cycle of any open cast mine is first is loading, then hauling to dump, then positioning at dump, then unloading, then receiving loading assignment, then hauling to shovel, and then positioning for loading. These are operational cycle of open cast mine which we have to monitor with the help of GPS. So there is a GPS-based lead monitoring systems chart that it helps quality control of ore, automation, equipment vital sign monitoring, 3D plotting, and auxiliary equipment tracking. Then I had shown two diagrams which based how we can analyze the condition of HAMM with the help of GPS-based lead monitoring. So basically, we set a dispatch room and then we connect wireless LAN to our dumpers and shovels to monitor how the operations are going on in our open cast mine. And with the help of GPS-based lead monitoring, we can monitor which dumper is operating in a productive way, and which is not operating. Which and also shovel's productivity is also analyzed with the help of GPS-based lead monitoring system. So this will help in future for our monitoring system. So next, let us move with the next slide. So our next solution which I want to give for my presentation is Google real-time traffic control. So basically, whenever we stuck in traffic, we always want to find a route which is situated in less traffic area and easiest way to travel from one place to another place. So these concepts we can use in our mind also, and we can make a Google-based traffic management system for our basically dumpers, and it will help us to uh, analyze a best haul route for movement of shovels and dumpers from one location to another location. It will help us to analyze front end development of our Google-based traffic management system, and this is back end, how the back end Google-based traffic management affect our HMM productivity. And we can use this concept for our lead monitoring and improve productivity of any HEMM operation in OpenCast mine. So before knowing this kind of solution, let's see what are the shortfalls in our existing technology, which we have to overcome in upcoming days. So OITDS utilization. First, we all know that major open cast mines with economies allows use of OITDS system, but dynamic allocation of machine is still under unutilized decision making, and decision making through OITDS based data is still lagging. The next shortfall is conditional monitoring. Conditional monitoring also lacking in existing technology because of maintenance and health of HEMM is not integrated with OIDDS data, and the data generated through OIDDS could not be utilized for better maintenance of machinery, and ultimately leading to poor utilization of HEMM occurs whenever we fall in our conditional monitoring. Then haul road maintenance is also not going properly in our open cast mine, because haul road maintenance is still based on subjective decision, and lacking prioritization of mine preparation activity leads to less efficient haul roads making, and AI-based prioritization can improve overall economics of mine. So these are shortfalls in our existing technology which we have to improve if we want to increase productivity of our open cast mine. So then I had given an example that how truck dispatch system helps in NALCO after implementation and before implementation effect. So these are some data which I collected from internet, that after implementation of truck dispatch system, how dumper performance and loader performance increased in NALCO, and these are some data which we can refer for truck dispatch system for our mines also if we want to increase productivity. So this is a good initiative taken by NALCO. So after this, let us see what kind of component that AI based artificial intelligence based truck dispatch system integrates. So components are agile components. Let us see first agile component. So decision making shall be under through results obtained through the system. An agile approach should be adopted in our mind. Next component is truck dispatch system. As we discussed earlier, truck dispatch system will give a efficient way. But if we enable AI based truck dispatch system, so it will increase productivity of our mine. An ordinary truck dispatch system with GPS-based surveillance of all HEMM will increase surely productivity of any open cast mine. Then artificial intelligence. Then data analysis shall be based on AI-based support. So if AI is supporting in our data, we can utilize data more efficiently. And next component is integration. If we integrate data generated to HEMM in the system, this will help us in future to increase productivity of our open cast mine. So let us move our next slide. So let us see what are the applicability of OITDS in lean monitoring. As we discussed earlier, that OITDS is major concern for our project. So let us see what kind of problems we see in our today's system. So these are problems are like bad whole road condition, lack of maintenance, not a perfect gradient, traffic hazards, and allocation of machine or HMM operator not in a proper way. After we implement OITDS system, what kind of solution it will provide? So after OITDS applicability, dynamic control of movement of dumper and operation of shovel will occur, and monitoring performance of individual machine and operator. And after this, improvement of operational efficiency of mine by virtue of online real-time monitoring will help us in future. And OITDS application are another application which help better communication between the equipment and control station, and it offers real-time online continual documentation. And after this, automatic route optimization through dynamic allocation system, and it suggestion alternative path in case of bad haul road condition. And it also provides online attendance recording system and automatic allocation of operators, and key production and equipment status information available over it. So these are the applicability we can apply in our open cast mine, and with the help of OITDS based system, we can increase productivity of HMM. So let us move to the next slide. So in this slide, I want to show that implement of OITDS open cast mine, how they are going to increase HMM productivity. So I discussed earlier, 95 production come from open cast mine, and only 20% of our open cast mine use OITDS system. And new open cast mines is a problem because we are not able to open cast mine everywhere. So if we want to increase production, we have to increase productivity, not number of open cast mines. So it will be problem. And after implement of OITDS in new open cast mine, if we open new open cast mine and we apply OITDS based system, it will set a benchmark for our existing mine and employ OITDS in our new OC, improve productivity of our mine. So let us see that before implementation and after implementation effect, what kind of role plays OITDS based system. So these are the effects which we can see after and before implementation of OITDS in our open cast mine, like vital sign monitoring system and maintenance is improved before and after. Attendance allocation communication of the operator is improved. Dynamic allocation in effective mine is also improved when we implement OITDS based system. And at last, I had presented a data which is based upon Giant Opencast Mine, that how OITDS installed Giant Opencast Mine and improve productivity. So we can see this graph, that how this graph is increasing when we implement OITDS based system in Giant Opencast Mine and increase productivity. Then I presented a report and improvement in our productivity, that how after and before implementation of OITDS based system and lean monitoring increased the productivity of this open cast mine. So at the end, I want to conclude my project that for large open cast mine, area is very, very vast, and we want many kind of and many number of heavy earth moving machinery. So appropriate management tool is essential to monitor and optimize mining's productivity. And next is that GPS-based truck dispatch system is an excellent tool for serving the purpose of great extent. And AI-based lead monitoring system is the best way to increase HMM productivity. And at last, I want to say that monitoring, then eliminating less productive factor will increase productivity and production of our open cast mine. So this is it. Thank you for giving me this opportunity. Thank you.
Thank you, Anjali. Can you hear me?
Yes, I can hear.
So this is a theoretical exercise, or have you taken some information from our mines, Tata Steel's mines?
Sir, actually this is the open project, therefore I had not taken exact data from Tata Steel mine, but I had learned like Joda East Iron Mine and South Bokaro is using truck dispatch system and fleet management system for increasing productivity of shovel temper combination. But this is not a specific Tata Steel's project. It is a general topic. Therefore, I had not taken a particular Tata Steel's mines example.
Okay, no, that's fine. You know, see, when Tata Steel mines, as you rightly said, we are having FMS. Okay, this is
Yes, sir.
exactly what you talked about. You know, fleet management system.
Yes,
And
yes.
the other point is that, you know, lead distance and FMS are really two different subjects. Okay, it might have interlinkage or between these two, but lead distance, even if you wish that you will not be able to do much, because you know you do excavate from a particular place and there is a place where you actually dump OB. Okay,
Yes,
so
yes.
it's not that everybody knows what's the shortest lead distance, but you do not have the choice every time that you will find no, to dump the material somewhere. So my limited points for you could be one or two. One is, you know, generally when you do analysis, I have not seen much analysis. You have 4 M's. I hope you understand that: man, machine, method, and you know, material.
Yes,
So
sir.
according to you, what would be the most important factor if you have to optimize lead distance and you know, vehicular movement or whatever? So what between these four, what will be the most important for an organization? Man, machine,
Can
method,
you,
or material?
okay, man, machine, method, and material. Sir, according to me, method is the most important point.
So
Sir,
machine is not important.
because, sir, can you please repeat? I'm not able to.
I
Yes,
said
sir.
when you method is important, so machine is not important.
Sir, actually, your voice is lacking. Therefore, I'm not able to listen to you.
You can't hear me.
Sir,
But I can hear Shishandu very clearly.
Hey, again, I guess there's same problem like Chaya. I hope that is
sir,
not the
I
case.
had not said that man and
Yeah. Carry on. Yeah, Anjali, carry on.
hello.
I can hear you.
Yes, sir. Yes, sir. Sir, can you please repeat the question because due to some network issue, I'm not able to hear you properly. Just it is a small request.
No, I understood. You know, unless you do a practical, you know, data simulations and understanding of a root cause analysis, you'll not be able to find out that which M would the most contributing, no, in terms of both for FMS and also for the lead distance project. Okay, so I think that's
Yes,
what I said. It's a more of a theoretical exercise, not with a a lot of data. So therefore, if you analyze informations, they will appreciate that how much HMM is responsible, how much is the people are responsible, how much the FMS is giving correct information, because you simulate data and you get an output to compare that what FMS is throwing at us and what we are actually achieving. Is there a difference between these two? So that's a little
yes.
observation because I don't have any real comments on this. Thank you.
Thank you, sir.
Anjali, good afternoon. Satish Tiwari this side.
Yes, sir. Good afternoon, sir.
Good afternoon. If you come to slide number 7, where you have mentioned AI-enabled integrated truck dispatch system, one of the enabler is agile approach shall be adopted.
Yes, sir.
What do you mean by that, agile approach?
Approach really a soft
Hello, am I audible?
or yes, sir.
So what
Yes, sir.
do you mean by agile approach?
I'm not able to hear you, sir.
You have mentioned that agile approach should be adopted. What do you mean by agile approach? Can you elaborate that? Am I audible to others?
Yeah, loud
Sir,
and
I'm
clear.
not able to hear.
You are audible.
Anjali, am I audible now?
Yes, sir. Now you are audible.
So what do you mean by agile approach? Can you elaborate that?
Agile is basically a software. We can say that agile approach is basically a process of extracting maximum things from that particular thing, and we can put this agile approach for our drug dispatch system because it is basically a software, and it helps us to make decisions and different kind of decision like HMM is operating in a particular way. uh, this will help us to increase productivity of HM.
So forget about your project related with this productivity of the HEMM. Just wanted to understand what do you mean by
Yes, sir.
agility or agile approach?
Increasing productivity, increasing any efficiency of any particular thing with the help of artificial intelligence. This agile approach helps us in that particular way.
That we have already mentioned at the bottom right side using the AI based analysis and all these things. Is it same?
Yes, yes. Sir, it is same, not totally same, but we can connect these points together to increase productivity.
Okay.
Yes.
That's all.
Yeah, Anjali, good afternoon. Surajit here. I just have one small point. Your recommendation slide, this giant open cast mine. So this probably is output which is you have used in your study, which is from maybe from net. Is it a
Yes, sir. Yes, sir.
yeah? So I mean, we have this kind of a system already existing within works, within mines, which Mr. Sindhu was talking about. So I mean, my limited submission, I mean, little bit of originality we were looking for, which is connected what Mr. Srishindu was talking. We need, with any problems which has been encountered at our plant, and your recommendations with this. Your work is very good. In fact, fantastic. You have been able to get a lot of input, and I think I see you have done some outputs also on the OR IT platform. So thank you. I think that is what I was trying to. Thank you.
Thank you, sir.
Thank you. We would like to thank all our jury members and our participants. Thank you so much for that presentation. And now we would like to ask you, do you want Chaya right now, or we can continue with our presentations and have her in the last?
Should I leave this meeting?
Yes, thank you, Anjali. Yeah.
I think we should complete Chaya if she is able to join.
Okay, Chaya. All right. So can we have Chaya, please? She able to join? Yeah, so we have Chaya here with us. Hi, Chaya.
Hi, ma'am.
Okay, finally. So you are here. We request you to please continue with your presentation ASAP, and then we'll move on our Q&A session. Thank you. Over to you.
Okay, ma'am. So now in case of dumper, it's not. Now in case of dumper, for aerodynamic drag, we can use underbody trailer skirts and can attach disc on wheels. It can save 1 to 10% of the fuel consumption. And in case of tire pressure monitoring and inflation, so properly inflated tires minimizes rolling resistance, wear and tear on tires, and also avoids the tire blowouts while driving. Haul road. So good haul road reduces fuel consumption by 30% and increases tire life. So dumper should be driven within speed limit because higher speeds increases the wear and tear on the tires. Operator practices. Operator should be skilled enough. If not, then they should be trained. Rolling resistance. So for minimum rolling resistance, we need to maintain these parameters like road, tire pressure, truck speed, and payload. And at last, guided spotting system instead of bucket spotting system, because it eliminates truck repositioning, reduces travel hang time, and facilitates dual-sided loading. And here are the references that I have used. And at last, I would like to thank Tata Steel for providing me such an opportunity, and my mentor, Mr. Brajvinod Kumar sir and Mr. Devadatta sir, my family members, friends, and my professors. Thank you.
So thank you, Chaya. Can you hear me?
Yes, sir.
Okay, good. So finally we could get you back on the screen. Okay. So I have quick couple of points. I think you have analyzed operator wise now fuel consumptions and also
Yes.
machine wise. Okay. But
Yes, sir.
as your presentations, you have also mentioned that, by simply comparing one with another may not be good because the conditions are different, the dump load quantity could be different. So did you have a proper understanding on those four parameters, which is fundamental of root cause analysis, man, machine, method, and material? Okay, which contributes what? How much is being contributed by the operators? How much is because of the haul road? How much is because of the machines are not maintained well? So did you have any understanding on this?
Sir, exact contribution cannot be said, but I can say that firstly, machine plays important role because technology and days of the machine comes first, then operator, sorry, sir, then method, because the method we are adopting for it obviously affects our fuel consumption, and then operator, because operator should be aware that which method is it is using, it is working efficiently or not. And then sir, last one was what, material, sir. So last one is material properties.
Yeah. So again, I'm repeating. Are you aware of a concept called Pareto analysis? Have you heard of it? Pareto analysis.
Yes, sir. Yes, sir. 80-20 rule.
So 80-20 rule. So in a 80-20 rule, at least you should be able to identify now that even an organization, let's say Tata Steel, you have to approach this problem for a solution. Then you approach it's vital few, not looking around everything. So based on this understanding and project you have done, what do you feel that what would an organization do to optimize or to reduce wastage, to optimize performance? What will you do?
Sir,
That's
actually
not
the
very
topic,
clear because you have mentioned everything. I want to be very specific points. That's my limited point. Carry on.
so actually the topic was about optimization. So I have to show that by which method we can make the diesel, we can use the diesel in its most effective way. So I have suggested the methods, like we generally ignore such things like we don't pay much attention to speed, the tire pressure, haul road conditions, but these things affect. So this will enhance the fuel consumption, but for considerable amount, we can think of other alternatives too. So that's
Okay,
it.
but these are the bread and butter of a mining guys, huh? Haul road and all this stuff. You can't say that, and I think nobody can say that you don't work on this. Anyway, thank you. Thanks, Chaya.
Thank you, sir.
Chaya, good afternoon. Satish Tiwari this side.
Good afternoon, sir.
I have one specific question. You have mentioned that one of the shovel E584 is most efficient or least diesel consuming.
Yes, sir.
So other than operator's skill, is there any other factor? You have also mentioned in some of the dumpers where some dumpers are more efficient in terms of diesel consumption. So other than operators' skill, what else is what are the other key factors for their being efficient?
Okay, so for working efficiently, productivity is efficiently, productivity is one of the factors. So in ton per hour, like it has handled 497.11 ton per hour of material, which is most handled material, and it has also consumed least fuel. So I came to the conclusion that it is working efficiently. And other factors like different run hour, because if the machine runs more time, then it will consume more fuel. It is obvious. So different run hour, different amount of material handled, and number of trips. Yes, sir.
If it runs for a longer time, then it means that it is working for a longer time, and that is what is desired.
Yes, sir.
So this is what is desired. We don't want idle time. We want the equipment to keep operating, keep working.
Yes, sir.
Why this should be taken as a disadvantage?
So it is not taken as a disadvantage. If it will work more time, then so we can consider liter per hour analysis for fuel. We can say if the machine is working efficiently, then we would have to take in consideration liter per hour. So I have shown analysis in liter per hour also to reach to the conclusion. So analysis in liter per hour and liter per ton, both I have considered.
Okay. Second question is that nowadays we are talking about alternate energy sources. So that I am not seeing anywhere coming into your. Why not to totally eliminate the diesel? So why you have not thought in that direction? Any reason for that?
Actually, yes, sir. Actually, the topic was about optimization. So I have to show only the things which can make diesels in. We can use diesel in most effective way. But I know the other alternatives, like we can use liquefied natural gas. It extends the life and performance of engine, and also its carbon emission is zero, so it's environmental friendly, and also the cost efficient, and also the temperature required for it to be liquid is minus 260 degrees Fahrenheit. And other thing we can some adopted it, like the first company was Alpha Coal Waste Company in Queensland, Australia, who have adopted LNG as their fuels in June 2012. And currently, Coal India Limited is in collaboration with GIL Limited and BEML Limited is retrofitting its diesel dumpers to LNG kits. And second alternative is we can use electric shovels and electric dumpers. So in case of electric shovel, actually due to removal of diesel engine, fuel system fuel tank, and air filtration systems, it becomes lighter and also applies lesser pressure to ground, and it is already available in from 8 meter cube to 80 meter cube bucket capacity. And if we talk about electric dumpers, then the dumper Coma TS2 HD HB6057 is an electric dumper who works on the principle of regenerative braking. When it goes up, regenerative braking. When it goes up, it doesn't. But when it comes downhill, it generates the power of 88%. So overall, it is generating the energy instead of consuming it. So it is one of the best alternatives we can use in our mind. That's it.
Okay. Thanks. That's all from my side.
I have no questions. Thank you for the.
Thank you, sir.
I have also no question.
Thank you, sir.
Thank you so much, Chaya, for the presentation.
Thank you, ma'am.
You can, yeah. So thank you so much for being so patient with us. And it was an interesting presentation. Let's see what our jury members have to say. So we'll get to know at the time of results. Thank you so much. You can exit this meeting.
Thank you.
Yeah. And now let's move on to our next participant. So we have our next participant is Dhara Sharma. Can we have Dhara Sharma here, please?
We have done 5, if I'm not wrong.
Yes,
Another
yes.
5.
Yeah, yeah. So now we have Dhara Sharma. So we have 5 left now, including Dhara. Yeah. So once again, would like to thank our participants. Thank you so much for being here today and all our jury members for being here today. And now let's move on with our next participant. Can we have her here, please? And as you all know that every participant get total of 20 minutes, 15 minutes is the presentation and 5 minutes is the engagement with the jury members. Let's move on to her. By Tata Steel. Yes, they are about Tata Steel. 50% of UK car makers fulfill their steel requirements from Tata Steel UK. Well, that's quite an amazing fact. And 75% of Singapore's scrap is consumed and recycled by Tata Steel. Well, and 4 million households served by Tata Steel retail brands such as Tata Tiscon, Shakti, and Dura Shine. Well, every fourth stainless steel utensils in India is made from Tata Steel chrome ore. So these are quite interesting facts about Tata Steel. We never knew, this organization was so diverse and extremely dynamic. And now we are over here, motivating and inspiring our participants to prove their mettle today. Let's see who wins. And we have Dhara with us. So Dhara, are you ready?
Yes, ma'am.
Okay.
Am I audible?
Request you to please move on with your presentation. Best of luck to you.
Thank you, ma'am. Ma'am, is my screen visible?
Yes, yes, it's visible.
Yes, visible.
Yeah. So, good afternoon, everyone. This is not about creating a giant, it's about creating the sustainability of the steel industry. Myself, Dhara Sharma, third year undergraduate from Department of Mechanical Engineering, IIT Kanpur, being inspired by this industry, did a case study on reliability improvement at continuous galvanized line skin fastening. So, firstly, we should know what reliability is. It is defined as the probability of a machine operating without failure. This may be stated in a like percentage form as the total scheduled time minus the unscheduled downtime. That is the actual operating time by the total operating scheduled operating time. So moving on further, we will analyze everything and come to the conclusion. So what is continuous galvanized line? Continuous galvanizing process is it is the process of continuous steel strip is coated on the both sides with a zinc material, which improves the corrosion resistance of the final product. Sheet surface is cleaned to remove oil, surface oxides, iron fines using rotating brushes and caustic soap. Then it is preheated to a low temperature and reducing of time required to anneal, and the sheet is put into the reducing zone for the annealing. So we should know what is annealing. Annealing is a heat treatment process that changes the physical and sometimes also the chemical properties of a material to increase ductility and reduce the hardness to make it more workable. So once annealed, it is cooled to a temperature roughly matching of molten zinc. which is done to avoid compromising the coating adherences which can arise from the sheet's temperature that is too high. After annealing, cooling is done. Sheet is passed to the molten zinc at a speed of 650 frequency per minute, and the sheet drags molten zincs on it and on its surface and exits the bath. So gas knives are used for this. And once coated, sheet exits the bath. It is cooled. Zinc solidifies on the surface. A strong metallurgical bond is formed by diffusion to form alloy layer. So now moving on to the main focus of our project, which is the skin pass mill. His main purpose is to give desired surface texture to the strip, and it suppresses the yield point elongation. In material, uh, it consists of two backup rolls and two work rolls, and a roll four cylinder, bending four cylinder, and all. So we use backup roll to support work rolls to increase the power of the rolling mills. So in this like diagram, we can see there are two backup rolls, and below it are the two work rolls and roll force hydraulic cylinder and all. Now, the functions of the skin pattern: adding a definite degree of roughness to the strip for paintability property, and surface defect elimination and enhancement of physical properties. Now, what are work roll bending forces? The contact pressure concentration that exists between work and backup rolls have direct influence on the shape and quality of the strip. The thermal crown is another factor that influences the control of the flatness and occurs in cold rolling mills. However, it is more critical in hot rolling mills applications. The analysis of the distribution of the stress and deformation of rolls for the rolling processes is based on the FEM concentration, that is finite element method, considering all the possible combinations of crown shape. Positive, negative, and flat. These are the three possibilities. Negative crowns will be used to simulate wear. Details of mill hydraulic system will be shown on the slide. The bottom backup roll is moved vertically by roll force cylinder controlled by servo valves and electronics which act as closed loop position servo, which implies it is used for cycle of feedback, error detection and correction when the rolls do not contact the strip, and as a pressure servo when the work rolls contact the strip. There are mainly four positions: rolling position, short position, long position, and full open position. And these are all marked on this. Uh, in the next slide, it is marked like this. So the short position is 5 mm below the strip rolling point, and long is 35 mm below the strip rolling point. And the full open position, the roll for cylinder must stop 8 mm before the full open position until the lower drive stops. Now, the operational details of the skin pass mill. There are 9 distinct states of operation, which are reduce force to a nominal value, mill at rolling position drives on, and reduce force to 0, short position open, long position open, full open, long position close, short position close on strip, and calibration. Then that is full open with the vent valves. So now we will define cold rolling. So, cold rolling. Cold rolling is a metal forming process where a sheet metal is compressed and squeezed between rollers at temperature below recrystallization levels. Sheet thickness is reduced by 0.5 to 1% to achieve a smooth surface. Now, what are the cold roll strip defects? At the end of the production process, cold rolling, whether it is cold rolling, annealing, strip temper rolling, and surface coating applications, there is a risk of stability loss of the coil and the formation of shape defects such as folded structure distortion due to sagging under their own mass, axial displacement of the turns in the coil, mutual slip of the turns, and consequent surface damage of the strip and uncoiling of strips over the thickness. And there occurs pinching. During rolling of metal sheets, defects may occur such as local waviness, surface ruptures, and sometimes strip breaks. It occurs due to the uneven pressure applied on the sheets. This may happen because of the uneven cylinder position at work side and drive side for any issue with cylinder pressure or work roll position. Now, we will understand the current issues at the skin pass mill. The first is zero tilting values are abnormal after mill gap zeroing. The values come in the range of 0.1 to 0.8 mm. Even for that, we need to insert shim. What is a shim? A washer or the strip used to align parts, make them fit or reduce wear. Above top backup roll, chalk before zeroing. Currently, we are inserting shims between 0.4 to 0.12 mm. 1.2 mm. This condition is for the last 3 to 4 years. Before that, we used to get the zero tilting values in the range of plus minus 0.05 mm, and we can see that there is a good amount of increase in the zero tilting values. Now, differential force is always on new thing like operator adjust the test values to reduce the differential force to normal values like plus minus 50 kilonewton range, but it does not hold. Even if the same coil passes through that, the differential force automatically changes. So we have to adjust it again and again. After the well pass with reduced force, again the differential force changes even without any change in the incoming material or any change in the skin pass mill settings. Another peculiar problem is that with differential force negative, that is theoretical more resultant force in drive side of strip, but pinching and waviness comes in the operator side. Then operator has to operate with very high differential force on its side so that the different it will be balances the like there is no defect in the strip. So the negative differential force value may get up to the as high as minus 100 kilonewton. So the bending volume changes very slowly if set point is changed from positive to negative and vice versa. At times, bending hunting is also observed causing chatter mark on the strip. HGC servo valves and controllers also malfunctions frequently, which need to be checked. And HGC cylinder tuning has not happened in a very long time. That is time response has to be checked properly. Now, this is the graph defect of the percentage of the total defect due to the skin pass mill. And we can see that what is the target value is 0.06 and we are getting much higher than it, that is 0.21 we are getting. So we need to improve upon this value. Now the current philosophy of skin pass mill. What are the observations? The observations we did are that like backup rule needs to be changed after a processing of 12,000 tons of steel, which implies 3 shutdowns in a month, and each backup roll change activity requires 6 hours. In current scenario, we cut the strip, do roll change, and then we go do gap zeroing, which we have to rethread the strip and do brazing. Entire process involves multiple time isolation, desolation, and all this happens because of the strip cutting at skin pass mill. And next, as per the skin pass mill OEM expert, gap zero needs to be done even after work roll change, which happens after every 1500 ton of steel production. In current scenario, it is not possible. So the recommendation is that if we can explore the possibility of gap zeroing with spacer, we can reduce the time by 3 hours and in every shutdown. This is mentioned in OEM manual also, and this is yet not established. And we can do gap zeroing after each backup roll change and each work roll change also. The current philosophy of the maintenance practice at skin pass mill is in the mill, gap zeroing after backup roll change, all temper fluid nozzles cleaning should be done, and SAP based preventive measures and inspection should be done. In mill hydraulic system, oil reservoir level, temperature inspection should be done. All hydraulic pump pressure checking, hydraulic oil cleanliness measurement should be done after every 2 months. Accumulator nitrogen pre-charge pressure checking should be done every 6 months. And all hydraulic valves thermography analysis for any internal leakage. Internal leakage through valve can result in a system that operates inefficiently and impact the pressure, temperature, flow, velocity, and other parameters. So this type of leakage will most likely result in equipment inefficiencies, leading to inconsistencies in the process that rely on hydraulic circuit. Accumulator thermography during service to know the working should be done, and all hydraulic actuator inspection slash replacement should be done time to time. And all hydraulic pump internal leakage case and measurement for knowing the pump surface life, as I mentioned earlier, also should be done properly. Now the recommendations should is like mill calibration. Mill calibration with spacer to save the strength duration, because in skin pass mill manual, it has been mentioned that 2 types of calibration, mill zeroing can be possible, but we fail to do calibration with the spacer. Hence, at the strength duration, we need to cut slash brace the strip. So this is the responsibility of the operations team maintenance. So as like after each work roll change, mill must undergo calibration, but in current practice, it is not possible as we cannot stop mill after every 3,000 ton production of like after 3 days, which is a work roll change schedule. In skin pass mill, servo valves are vital installations in the hydraulic circuit. In current practice, we cannot assess the health of the servo valves as per the SPM. So we measure different servo valve characteristics in definite period. This can be developed. So current practice, we inspect the accumulator pre-charged nitrogen pressure. For this activity, we need to put watch and measure the pressure. During this activity, Some pressure drops during fitting, connection, and disconnection of the gauge. If online pressure measurement can be done, then productivity can be improved or will be increased also. Fast line checking with respect to the drawing. This will ensure proper gap zeroing should it will be in the position. Calibration sensors can be used. Pressure transmitter, position sensors are also a vital part. So we discussed like we can use spacer. So we should know what the spacer is. Spacer is the shaft wheel. It is an important part used with the roller in the roll forming machine, and spacer used to fix the rolls in the correct position on the spindles. Vertical adjustments of the top shaft fine tunes the machine to accommodate specific rolls and material thickness. Some other recommendations can be given, like we can use camber. We can apply camber to it. And is a camber? An increased diameter, diameter at the end of the middle of the rolls, designed to counterbalance the bending of the rolls when they are subjected to a high pressure during the rolling process. We can apply camber on rolls in the opposite direction, and the surface in contact with the sheet becomes flat after deflection. Then we use hydraulic jacks. It works well in the instances where wavy edges occur. And these jacks control the elastic deformations of the rolls as per the requirements. Also, the use of small diameter roll works efficiently. So one recommendation that I thought can be possible, but I discussed with the mentor, like it is not, it is beyond our scope at this point of time. That is the edge effects occur due to uneven heating, uneven rolling or excess quenching. So this should be checked properly, and we can use trimming operation to remove edge cracks. But it is beyond our scope. Also, stretch and roller leveling under tension might work against the edge cracks. Using edge rolls might help in achieving uniform rolls without any cracks. The edging process removes the burr and establishes radial corners on the material. It removes the burr and it helps to improve the edge part of the art. Now, concluding the part, we discussed about the skin pass mill, its functions, issues faced in it, and some recommendations which which contribute to the improvement of the reliability of the skin pass mill. At last, I would like to thank Tata Steel for giving me this opportunity to present my a project in front of this great jury, and also I would like to thank my mentors for supporting and guiding me throughout the project. Thank you.
So Dara, this is Anurag.
What's it? Yes, sir. Hello, sir.
This is Anurag Saxena.
Yes, sir. Good afternoon, sir.
Good afternoon. So this is about improving the reliability. Okay.
Yes.
To improve reliability, we focus on MTTR and MTBF. So have you heard this word, MTTR and MTBF?
No, sir.
You have not.
Yeah.
You have not heard this word. Okay. So in your presentation, you told that one of the method to detect the leak in the valve is thermography.
Yes.
How thermography can detect the leakages, internal leakages?
So, yes, I'll move on that slide. So I mentioned like the all hydraulic valves are like thermography analysis for any internal leakage should be done. So thermography will tell about how much like a fluid is leaking, and it will detect the leakage.
Thermography will tell you temperature profile. Its name is thermal. So it will give you
temperature changes occurring during the flow.
So that is the question. How a thermal picture will give you some idea about the extent of leakage, zero leakage,
Yes.
leakage in
The thermal, like when the temperature changes, it will also affect the pressure of the flow of the fluid. So it will tell us the.
And then we should measure the pressure. If leakage is related to pressure, then we should check the pressure, or leakage can be identified through the reduction in volume. But you are telling that by taking a thermal picture of a system, you will tell the leakage. That's what I wanted to understand.
So I thought that like that way we will analyze the temperature profile of this fluid, and through which we will get to analyze the pressure and difference. And
Okay, so this last question. So you are telling that there are servo valves.
Yes.
So how servo valve is different from, let us say, pneumatic valve and hydraulic valves?
It is highly efficient and it is like compatible also, and it is
efficient and compatible is efficient means what? It consumes lesser energy. What do you mean? What do you mean by efficient?
efficient means like
Use the word in terms of control.
work control valves, like in that sense, I should say.
Yes, there is pneumatic valve, there is a servo valve, there is a hydraulic valve.
Yes.
What is the difference? Which one is more accurate?
The servo valve is more accurate because it is more
This
efficient.
is an intelligent guess. Yes, good. Why?
Because it like output as compared to the other valves we use when we provide some input to the servo valves, its output is more efficient as compared to the other valves we use, like hydraulic valves and all. And
Hydraulic we use fluid to operate. In servo, what is the energy is used to operate the valve?
mechanical energy.
Mechanical energy.
Sorry, electro-hydraulic servo valves are used, and it converts the electrical energy to the mechanical part.
Okay, thank you. Thank you, Dara. That's all from my side. Okay.
Good afternoon, Dara. Satish Tiwari this side.
Good afternoon, sir.
Your project was to improve the reliability of CGL2.
Yes.
But which factor brings down the reliability? Which is the most important or biggest factor which brings down the reliability of CGL2?
So in terms of like we can say, as I mentioned, the definition of reliability, we put it in the percentage, like actual actual time by the total time taken. So actual time is defined as the total time minus the when our machine goes to the downfall, like down point. So the reliability is defined as the key when our machine goes to the down and again starts, then it should be operating without any failure, and it should be continuous, as the name suggests, continuous galvanized line. So it should be continuous and it should work without any failure or any breaks, and should be efficient also, will not affect our production also. I think that will define it.
Is that what affects the reliability? Which factor? Which matlab assembly? It is hydraulic problem, mechanical problem, electrical problem, operational. What type of problem? Where we should focus?
I think it's a mechanical problem. The force part, as we put the hydraulic cylinders, bending cylinders, there is a difference in the pressure values. So the forces applied on our sheets it differs. So I think the mechanical part, the pressure part, will affect the reliability, as the pressure will change the shape of other production part, the steel strip that we come out of that.
Another question is, you mentioned about some accumulators.
Yes, sir.
The function of accumulator?
Yeah, 1 second, sir. So as I mentioned, like in this accumulator, nitrogen pre-change pressure is used. Nitrogen is so accumulator. We use bladder accumulator. So in that helps us to maintain the pressure. As if the pressure changes in our fluid flow, so extra fluid will flow in the bladder part. It will change the shape and maintain the pressure. So it helps to maintain the pressure in our fluid flow.
Okay. Thanks. That's all from my side. Thank you.
Dara, good afternoon. Surajit here.
Good afternoon, sir.
Yeah, taking a clue from or a point from Mr. Satish's point, ideally, I'm not trying to recalibrate your project. Basically, you should have looked at OE, that is the overall efficiency. Is it because you are talking about defects of the rolled sheet? So
Yes.
it could be the speed factor, it could be the equipment factor. I think then if you had broken it down, it would have been much better. And then the flow, as I'm not from mechanical, but what I see, you are talking about cylinders, valves, and control systems to take care of the negative negative forces. So at one place it is recommended as spacer. How does the spacer look like? I think it would have been better if you had put a drawing of it. Then I think that would have made your presentations much more richer. So
Yeah, but I have not put the exact photo of the spacer, but in my like last second slide, there is a picture of like spindle and a spacer
yeah.
mentioned there.
So you could have done, you talked about camber also. So how does a negative camber, how does a positive camber look like? So that would have made your cases much more stronger. These are some my views. But anyway, this is a good presentation. I'm very happy that you have been able to present such a difficult and involved subject much better. I think, thank you. Thank you. That's all.
Thank you, sir.
Any more questions? All right. Thank you so much, Dhara, for this presentation. Thanks a lot. And
Yes,
now,
ma'am.
before we move on with our next participant, we want to know from you if you want a break for 15 minutes or 1 hour or whatever, it depends on half an
So,
hour.
Bhavita, before that, is Komal connected?
Komal, yes, sir, she's here with us.
Ma'am, can I like leave the
Yeah, you can
meeting
please
or-
exit. Yeah.
Thank you, ma'am.
So, Komal, are you listening to us? Hello? No, I wanted to know whether they have, I think they have not visited the plant.
I mean, I have left this, I'll keep this for the later part of the discussion.
See, like a FAMD case where they said ki duct lagana hoga and that is a challenging task. So if they had visited the plant, then they could have not considered that as a difficult part. So Komal, are you there? No.
So, ma'am, I think we can take one more participant, and
Yes,
after that, I think we can move.
Yeah. I think 135, 140 should break for half an hour, I would say.
Yeah. I think we can take one more.
Yeah.
And how many are left out? How many are yet to be
There are
done?
4 more left.
Char baki hai abhi.
Yeah.
Char bhai.
We have Ritika Soumya now. Can we have Ritika Soumya please here? Ritika Soumya, can you please join us here? Yeah. So Ritika, hi.
Hello, ma'am.
Hi.
Am I audible?
Yes, you're audible.
Hi.
So you're ready with your presentation?
Yes, ma'am. I'm ready.
Okay. So over to you, Ritika. Thank you so much.
Ma'am. Good afternoon, respected jury members. This is Ritika Soumya from IIT Jamshedpur. Today, with your due permission, I am going to present on the topic to study and develop an internal spare management model for RMHS mechanical maintenance. Here at the left side, you can see the flow of my presentation. And now, let's begin. At first, we will understand what is spare management process. It is a well-received saying that we cannot manage what we can't measure, and in RMHS, bulk number of spare parts need to be tracked along with its specification detail. In this whole presentation, our prime focus is on to identify the gaps in present spare management system and to produce an efficient and effective solution for the same. Spare part management in simple word can be defined as availability of right part in right quantity with right level of quality which cost least to the company. RMHS is divided into 4 departments. First is Mechanical Maintenance Supervisor. Their main job is to ensure and enhance visibility of each and every spare part. Then we have Procurement Supply Chain. They aim at keeping an eye on procurement pattern of each and every spare part. Then we have Storekeeper. They are responsible for manually updating the register at our RMHS kitchen store. At last, for making all decision planning and budgeting, we have Executive Director. On the left side, you can see there is a flow chart of material which is of our Tata industry, and from this one can identify how essential it is to ensure proper functioning of each and every spare part. Now let me highlight importance of spare part management. It is very necessary to identify each and every spare part along with its parent equipment, location of installation, and etc. Inventory cost of every industry is depicted as negative asset, and thus we aim at minimizing it by checking the accumulation of spare part which lead to excess storage cost, holding cost, carrying cost, and etc. Then comes downtime. Every industry have certain permissible limit of downtime, and each year they aim at minimizing it. By proper analyzing the breakdown and procurement pattern of spare part, we can deal with this downtime issue. Then we have mean time to recovery. It is the time from figuring out the issue to fixing it. There must be certain minimum defined level of inventory that an industry must maintain in order to deal with any unforeseen condition. Criticality of spare part must also be defined because many times our decision for procurement is based on it. With minimum inventory, we can use our assets more wisely in further upcoming projects. Now let's see some best inventory management practices. First comes economic order quantity. It is the optimum quantity that an industry must purchase in order to deal with breakdown as well as to maintain safety stock. Then we have bill of material. Bill of material is a detailed list of equipment which is necessary to produce an assembly. Then safety stock. As discussed earlier, it is the minimum inventory quantity which must be maintained. Safety stock plays an important role for determining the reorder point. Reorder point is the inventory level at which the industry must start procurement process so as to maintain certain minimum buffer stocks throughout. Here we have a graph. In this graph, the y-axis represents the inventory level and the x-axis represents the time. The sawtooth-like structure represents the inventory level quantity at a particular time, and the horizontal red line depicts safety stock, and the horizontal green line depicts reorder point. And the gap between adjacent peak depict the lead time. Lead time is the time manufacturer require in order to deliver the product. Let's see the spare part flow at our RMHS. It all began with a shutdown plan. This shutdown can be conditional based or time based. If there is a shutdown, then we will require a spare part. For this, at first we will check it at our kitchen store. If the part is available, then manual entry will be done at our kitchen store register. If not, then we will look for a central warehouse. If the part is available at central warehouse, then material requisition will be created and again manual entry will be done at our kitchen store. If not, then shopping cart will be created, rate flow quotation will be floated, and the manufacturer who meet all our demand will be given the order for procurement. And then again, the information will be entered in the RMHS kitchen store. In this whole process, there are some errors in our industry, and I would like to highlight them. At first, the safety stock for every commodity was not defined, due to which there was unnecessary accumulation of spare part. Then the register at our RMHS was not accessible to every worker there. The whole process of RMHS kitchen store storing process was manual based, pen paper based, due to which there was lack of visibility of product. No standardized format for all individual equipment was there, due to which the decision making process was difficult. Criticality of spare part was not also defined in our industry. To solve all this issue, I would like to present a model of mine. While preparing this model, I tried to make it economical, feasible, and practically possible for the company. Let us have a glimpse of my model. First, discuss the methodology of my model. A standardized format for storing data of every commodity was created and criticality was defined. A data collecting interface was generated so as to track the daily motion of spare part at our kitchen store. Let's see key feature of my model. Raw data was collected and was fed according to a standardized format for all commodity, which lead to collective commodity analysis easier. Then this model of mine stores, you can access to the data via my model with just a single click. This model of mine provides every minute detail of a particular spare, like location, manufacturer, price, UMC number, etc. This model of mine is not a static one. It keeps on updating itself as you feed a new a new spare or withdraw a spare from our RMHS kitchen store. These are the interface screen of my model. The first one is master spare list. And the second one is spare tracking list. Master spare list covers all the information which is required to identify a particular spare. And the detailed spare tracking list covers all information which is required to track a particular spare. In my model, I have provided easy to use button search option. The whole data of my model displays the data based on criticality wise along with its quantity, UMC number, mark number, make number, etc. It also depicts what is the quantity of UMC need to be procured and what quantity a particular UMC must be procured. Let's have a glimpse of other pages. I have also covered commodity wise specification of spare part. Let us for consideration select pulley. As you select a particular pulley, either by parent equipment name, component name, or by mark number, UMC number, the dimensional specification of the pulley will also be displayed. At the right corner, you can see mobile view. This whole model you can access on your mobile phone. You don't always need a desktop or setup for this. The working of my model will be more clear if you see it properly working. This is the first page of my model, which is spare tracking. In this sheet, you can see at the left bottom, 182 is displayed. That means 182 number of UMC need to be procured. And what is the quantity of procuring this UMC is displayed here in this table. As you can see, this particular UMC number need 4 quantity to be procured. At the top, you can see we have button search option for say apron feeder, belt conveyor. For this model, I have only considered apron feeder and belt conveyor as our parent equipment. For say I selected belt conveyor. Now the whole information here is displayed based on belt conveyor. You can also search by criticality. For say I selected A plus criticality. So we can see the whole information. This pie chart display what is the condition of our stock, either it is healthy stock or unhealthy stock or need any procurement. You can also search for a particular spare. For say I selected in parent equipment AF2 and the component name be adapter sleeve. We can see this particular spare of R is lies in a healthy stock. That means we don't need any procurement. It lies in apron feeder and spare categories adapter sleeve. Let's see some other pages. This is master spare list. Here, the quantity of a particular spare based on SKUs is displayed along with this component name. Firstly, I want to know how many components are there in pulley. So I just clicked on pulley and you can see component name based on pulley is displayed. Now I want to know how many of these components lies in A plus category. So I just clicked on A plus and these many components are of A plus category of pulley. Along with this, old UMC number, new UMC number, mark number, make number, install quantity is also displayed. Let's see some commodity by specification screen. At first, let's go with pulley, plumber block, I want to know about a particular pulley. So I can also select from this table. First say I want to know about this particular UMC. I clicked on it and this dimensional specification changed according to the this particular pulley. You can also search by how many pulleys are there of A plus criticality. So I tapped on A plus criticality and these many are of A plus criticality. You can also search by typing the name of the particular spare part. For say, I selected CO30 and component name be deflector pulley. There is no deflector pulley. We selected AF1 and I'm sorry for this lag. The model lags a bit because my system isn't that good. First, I selected CC1. Now the whole information here is based on this CC1 pulley or CO1 pulley, and the location of installation is also displayed. Let's see mobile view of this project, this model. Here is the mobile view. This mobile view needs a more work. Due to lack of time, I couldn't spend more time in creating mobile view. So you can access the whole analysis information on your mobile phone. Let's now see the most important part of this model of mine, that how it will help the company. At first, let's discuss economic benefit. As you can see, there are two visual analysis. First is of bearing and second is of low speed coupling. The deep blue line depicts the safety stock, which must be maintained. And for bearing, the available quantity is more than safety stock. And for low speed coupling, the available quantity is less than safety stock, which may lead to breakdown or other unforeseen conditions. From this, the workers can analyze that which part needs to be procured, and thus we can spend our assets or money more efficiently in procuring the spare part. Let's see some social benefit. The productivity of the whole process will increase, and there will be a transparency in spare part procurement department, and people can use their time in more important project. Due to lack of time, I couldn't work on some part of this model, but I would like to discuss that aspect also so that further work can be taken up. The first one is mobile view. As I showed you, the mobile view provide access to data anytime, anywhere. Then we have predicting values. With lead time given, we can know after 3 months for say how many UMC number need procurement. Then we have the whole model of mine is AI based. So you can just simply type what you are looking for and this model will produce an efficient solution for the same. This model of mine is used by the Tata Kalinga Nagar industry. This is the data collecting interface which I created, and the whole data is filled by the worker at Tata Kalinga Nagar. Apart from this model, I would also like to present some add-on proposal which I feel will make the whole process of storing spare part information much easier, which is tagging. Tagging is the best process for identifying a particular spare. There are various types of tagging process in the market, but I will only suggest those which have capacity to be used in our industry. First is ultra high frequency radio identification tool. From this, a large number of spare parts can be tracked all at once. Then we have color tagging. Tagging is used as Kalinganagar Tata Steel plant, but not at much extent. We can use it for identifying or differentiating between new product, refurbished good, or damaged good, so that there wouldn't be any mixing or confusion. Then rigid metal photo tag. Due to its durability, we can use it in open storage also, or for harsh condition also. Thank you so much. This was all from my side for RMHS maintenance, and here are my learnings.
So good afternoon, Ritika. This is
Good
Anurag.
afternoon, sir.
So how do you measure inventory? Very simple question.
So for measuring inventory, we have at the central level, we have central warehousing system who basically measures what is the quantity of spare part given to
What
a
is the
particular.
unit? What is the unit of measurement of inventory?
It depends. Like we count. In my model, I have given the number in numbers or in liters for some paints, other stuffs. Means mostly in my model, I include a number for withdrawal or addition of addition of
For
spare part.
different material, there will be various units, some numbers, tonnage, liters,
Yes, sir. I have included
packets.
numbers, liters, and set for
No,
this.
no. This is on single unit of measuring the inventory. Somebody will say inventory has increased. So what is the unit of measurement? Some packets, some tonnage, or So do you think that this answer is right?
So counting can be vary from numbers to tons also, because we are talking about
So
a
there are 8 types of measurement. So how you will complete your statement that inventory measurement is done in such a complex manner? Okay.
sorry sir, right now I'm not able to analyze it.
Okay. One last question is that have you heard about insurance spare? Because most of the things you were talking about consumable and fast moving.
Hmm.
Insurance spare.
Insurance bill, like the CWH is responsible for providing that spare part whenever needed.
No, no. So there are various categorization of spares. So spares are categorized in various ways. One
Like
of them
ARC,
is insurance
consumable.
spare. So what is the categorization of spares?
We have we have ARC spares, we have SS spares, we have PR spares, we have consumable spares. These four I know.
Consumable is correct. You are telling ARC spare.
Yes, sir.
So ARC is a method of procuring.
Yes, sir.
Okay, thank you. Thank you, Ritika.
Thank you so much, sir.
Hi, Ritika. Good afternoon. Satish
Good
Tiwari.
afternoon, sir.
So I have two questions. One is that what was the biggest gap, largest gap you have observed in RMHS system of spares management? And give me one most means top recommendation to take care of the gaps which you have observed at RMHS.
The first was as our industry is quite large scale, and the kitchen store of Kalinga Nagar was using pen, paper, or register waste, due to which they themselves admit that they are facing trouble for retrieving data or knowing that which product need uh, uh, procurement, or where is the location of that product, or they cannot identify at the means at the industry. When they are looking at a product, they couldn't identify that what exactly is this. If the person is not knowledgeable enough, they weren't able to identify if this is pulley, or if this is head pulley or snub pulley. That was, I felt, is that need to be resolved as soon as possible. And I feel my model and the tagging system at first is that the tagging system at first is most effective, because on field you can identify the spare part, and if you connect this tagging system with my model, you can also retrieve data that what exactly is this product, means what is the location, or what is this parent equipment, or what is this manufacturer, price, quantity, whatever information you want to retrieve.
Okay. Another question is in one of the slide you have mentioned about Gemba.
Yes, the Gamba activities, other fruitful activities.
What is that?
So Gamba activities mostly refers to other productive words. It's other language word, Gamba activities.
What is
This is Japanese. Other other productive works.
okay? Thanks. That's all from me.
Yeah, Ritika, just one question. This software operations
Hmm.
and this development, you have done it on your own, or you are being assisted by the mentors group, or you just uh, got the data together and did analysis?
No, sir. I first created this model and presented this model in front of my mentor. And afterward, they suggested me some corrections, like the unit. I didn't mention the unit part. So they asked me to mention unit part. And they also told me about lead time, means forecasting the information. That part they helped me. But initially, I created the model. And they provided me the raw data, so which I feed it in this model.
So what Anurag boss was asking regarding inventory, EOQ, reordering point, you are aware of all these things, no?
Yes, sir.
Okay. Thank you.
Thank you so much, sir.
Okay, so Ritika, one small point is on this modeling in inventory management. There are a lot of interface, no, in terms
Yes,
of
sir.
users, procurement. Does your model give a uniform view to everybody at some point of time in terms of, let's say, just give an example that, I need this material on 7th day. Okay, I am placing an indent, I need it in 7th day. Does everybody in the system know that whether this material will be available on 7th day based on the reordering time, based on the cycle time and everything? Is it
Yes,
captured
sir.
in your model?
Yes, sir. It is. It will be display. It will display every motion of the commodity, and we can also restrict the visibility for particular group. This model of mine have a visibility restriction facility also. So if you want that a particular community won't get access to my pulley commodity information, so they can't access it. But at general level, anyone can get access to this data if whatever the other person is doing with the spare part or whatever feeding or withdrawing they are doing will be notified to everyone other who are using this model.
Is it also connected to the vendor partner? Just I'm extending this point.
Hmm.
Let's say somebody has reordered it
Mhm.
and procurement has placed an order. So does someone get the visibility that, okay, this order is placed on someone, it will be delivered on 6th day, 5th day, 4th day? Is it
Yes, sir.
integrated that way?
Yes, sir, we can. Even we can connect this model of mine with central warehousing system. As in central warehousing system, as per my research, you put some code for your particular industry and feed your data. So you can connect this model of mine. So afterward, the central warehouse information and your particular industry information will also be displayed and analyzed in my model. These are some further expect which I wasn't able because I wasn't able to access spare part of Kalinganagar. So SAP of Kalinganagar.
So you have gone through the Kalinganagar. So I think
No, sir,
one
I
of the
didn't
most
visited there. It was online project, so but
no,
I
that's
asked
fine.
my
That's fine.
mentors.
No, that's fine. So my point is a little different.
Hmm.
Let's say you want to have a central warehousing, let's say for a Tata Steel. Okay, there are 5 steel plants. So how do you really connect everybody on board? Then the other point, the extension of your logic of tagging, code, which has to be uniform across. Then only the visibility will be there to everybody. No?
Mhm.
So
Yes, sir.
I think it's for Kalinganagar. So maybe somebody has to really extend it to further to other steel plants and understand that do they have the same system. Otherwise, it will be for a one location, not replicated elsewhere. Huh? So I think
Yes,
that's
sir.
a food for thought. I think that's we need to take it forward. Thank you, Ritika.
Thank you so much, sir.
Thank you. Thank you so much for the presentation. Once again,
Thank you, ma'am.
Ritika, thank you so much for joining us here. That was quite a wonderful presentation, and you can exit now. You can,
Sure, ma'am. Thank
yeah,
you so much, very members and ma'am.
yeah, you'll get to know later about the results. Yeah, thank you. Thank you so much for joining us. Well, that was Ritika, and now I would take your viewpoints. How you want to move further? If you want to take a half an hour break, we can proceed with the break. Otherwise, we can proceed with our presentation.
2:15. Yeah. I said 2:15. I think we should assemble. That's my view. Need to have lunch
2:15.
also.
Yeah, is that fine with everybody?
No, it's okay.
It's okay. It's okay, ma'am.
It's okay. All right, all right. So we'll meet here again. We are breaking for lunch now, and we'll be meeting here again at 2:15 and continuing with our presentations. Once again, thank you each one of you present here for being with us and for supporting it with us. Please enjoy your lunch. Thank you.
You.
Have you ever wondered what makes a company grow from small to big? How these big companies create and imbibe high trust and high performance culture? How they always manage to keep the workforce motivated? And how these companies bolster the nation and economy all together? Good human relations not only bring great personal rewards but are essential to the success of any enterprise. These words of J.R.D. Tata have helped build one of India's most successful enterprises, Tata Steel.
Tata Steel is a 100-year-old company, 110-year-old company, and the reason we've been around for this long is that we've continuously transformed ourselves. So one of the challenges we always have as leadership is how do you make an organization future ready? And I think we're in the middle of that journey, as we have been in the past.
In 1907, Asia's first fully integrated steel making operations began at Jamshedpur as the Tata Iron and Steel Company. The company continues to retain old values while adopting modern technology.
In the last few years, we focused on the structural transformation of Tata Steel. We've grown the parts of the businesses which are more profitable, planted the seeds of businesses which could be very profitable in the future, and hence the whole focus was on how do we make Tata Steel structurally future ready. We are currently also in the midst of what we call a cultural transformation. How do we make Tata Steel culturally future ready? It's about having a more innovative Tata Steel, a more inclusive Tata Steel, a Tata Steel which celebrates the diversity of its workforce, a Tata Steel which is focused on technology, a Tata Steel which is creating a sustainable future. We will make Tata Steel a future-ready organization, as it has been many times in the past.
The company's core values include integrity with the aim to steer clear in the public eye. Excellence. Tata Steel always strives to achieve the highest standards of quality. Unity by developing collaborative relationships built on a steady foundation of trust and mutual respect. Responsibility towards the environment and in business through profit sharing.
Tata Steel company where people come in, the best and brightest comes in from campuses, whether in technical areas or whether in HR or finance or marketing and sales and so on. And each one finds their own space within the organization. There are very structured, very facilitative programs for leadership development through the ranks and across the spectrum of capabilities. We have programs like reverse mentoring, where even a youngster can be a mentor to a much senior person on, say, digital journey, because youngsters are more familiar and more inquisitive on this area.
Pioneering by being unafraid to charter into new territories, take on new challenges and develop innovative solutions.
In general, innovation is in two buckets: continuous and breakthrough. In continuous, we are very good because we have been doing this for a long time and it has become a part of our DNA. For this, the requisite strategy, requisite engine and requisite enablers are in place. As a part of enabler in terms of culture, governance, talent and tools, from the day we join the organization, we are trained in TQM principles. We are encouraged to observe and innovate. Even TMDC has started giving us training on innovation. As part of governance, we have two sets of reviews, Impact Center and Lead Center reviews, chaired by the area chiefs and the vice president respectively.
Tata Steel is constantly reinventing itself. Its sharp focus on innovation, technology and sustainability has kept it in the race for over 110 years and has helped it emerge as a market leader. When it comes to Tata Steel, sustainability is key. The company operates in a way that is safe for the people and respectful to the environment.
It's the last chance to save the earth. It's the last chance to save this planet. This is the note that I read when it was shared with us in the sustainability campaign of Tata Steel. It stuck with me. I was expecting a child at that time. I thought it's my responsibility to leave a better world for our children. And that's when this thought of planting trees across stuck with me. When I joined back from my maternity break, sustainability team got me on board. No single-use plastic in my department was something which I did in a period of 1 month. We removed all the plastic usage from the bottle. I planted 100 trees on the birth of our daughter. All these was done when I was inspired by Tata Steel, with the help of Tata Steel. Tata Steel inspires us to work towards the environment, like going low waste. That was again a campaign run by Tata Steel across departments.
In India, Tata Steel introduced the 8-hour workday at the Jamshedpur plant in 1912, the Workers' Provident Fund scheme in 1920, the Leave with Pay scheme in 1936, all of which was subsequently adopted by the International Labour Organization and enacted by law in India.
We have created an environment in Tata Steel which is very supporting. And supporting in the sense that we make sure that people are taken care of in whichever way they want to. And that is why we have a number of policies. I mean, if you look at, it is Tata Steel which has come out with the 5-day working in a manufacturing setup in a plant location. No other, we were the first perhaps. We have policies of work from home, we have satellite policies, and we have a number of such policies which facilitates people to contribute from whichever part they want to, in whichever way they want to. And the only thing is that they should feel empowered and they should feel the ownership of what they're doing.
The company strives to create a work environment where employees don't dread coming to work on a Monday. Employees don't wait for the weekend to catch up with friends or pursue hobbies. Tata Steel's 5-day work week ensures they make time for these activities along with work.
When it comes to employee engagement, we are not just encouraged to excel at work, you are also encouraged to follow your passion. Like be it singing, be it dancing, be it fitness, or be it literature. There's anything, there are actually a lot of clubs which exist for each of these activities. And not only are we told to take part, we are actively encouraged that we should pursue all these passions. And if there's something that interests you or there's an initiative which you want to take, you should definitely go ahead and do that.
For me, Tata Steel has really given me the time, space, the people, and all what I needed to make what I wanted to make, that is music.
Apart from that, from an engagement, there's a very unique program that we have which is known as the Outdoor Leadership Program. So this is conducted by the Tata Steel Adventure Foundation, wherein we are taken for a 10-day trek to the Himalayas, and you have to sustain on your own, carry your own weight, cook your own food, and there are a lot of leadership traits which are taught along the way. So this is just the tip of the iceberg. When you actually go deeper, there are a lot of other things which constantly keep you engaged and amused at Tata Steel.
There is one famous quote: if you choose the work you love, you never have to work a day in life. So while working with Tata Steel, I feel the same. I'm getting paid to pursue my passion. I go and climb the mountains. As I have climbed Everest, but now my goal is to climb other 8,000-meter peaks, especially explore peaks in the Himalayas. And maybe one day I want to climb one 8,000-meter without supplementary.
Tata Steel also provides employees with several growth opportunities to experiment and the freedom to learn from failure.
Considering it was a 100-plus-year-old organization, I thought it will be moving at its own pace. But it has undergone a huge transformation. We are moving at a very fast pace. Any idea which I have right now, when I take it through my bosses, I'm given the full authority to go on and execute it without the fear of failure. With the ideology that it's okay to fail. You just go on, you should just go on and keep trying until you achieve something good. And that's how we have been moving at a greater pace.
They encourage employees to study further by providing incentives for higher qualifications.
Tata Steel has a culture of inducting courses for its employees to enhance their knowledge level. Whether it is a PhD at Cambridge or a PhD or a MTech or a MS in the IITs. So we have a plethora of opportunities and plethora of courses which are offered to the employees. It is up to us as an employee that we apply ourselves over there and we take the grab of the opportunities that are being thrown to us.
Coming here, the Tata Steel provides always that kind of a learning and development support in terms of best-in-class training, best-in-class infrastructure.
I feel like an organization which allows you to blossom. It's an organization which invests a lot in training and development, not only through the classrooms that they send you to, but through the experiences that you get. And the sheer variety of the organization, variety available in the organization is really mind-blowing. People don't realize, people know us as a steel company, they don't realize that we are one of the biggest mining companies as well in the country.
Work helps individuals interact with a diverse set of people. This diversity brings in different thought perspectives, ideas, and develops empathy among employees. The company's policies are centered around diversity and inclusion.
The diversity and inclusion journey, I think Tata Steel is right from the beginning, because we set up the steel plant in a place where there was no one. So people came from all over, including some local community, tribal people, to people who were engineers and specialists from across the country and the world. However, diversity took a new meaning as we went by. So it is not a CSR, but it is a reflection of society within your organization. And therefore, we decided in Tata Steel, the entire organization, that we will focus on 4 areas of diversity: women, persons with disability, the affirmative action community, and the LGBTQ. So we were very clear that these were the areas we want to focus in, not only in terms of just doing lip service, but putting a number to that, but not doing number for number's sake. That means there's no quota for all this, but this is what we would like to promote. So the journey, the top management to everybody was very clear that let's create an enabling environment so that people find it comfortable to join.
So all kinds of diversity which exist, we believe that inclusion of all kinds of diversity helps in bringing out the best in people, and hence the workplace that we have created, this workplace supports all kinds of diversity and includes everything together.
Infrastructural improvements have been made to make the workplace more accessible and comfortable to persons with disabilities. They also provide menstrual leave and counseling to employees.
See, the working environment, when it comes to any of the workplaces, I believe it should be looked at both the perspectives, like personal and professional. Say that because I have certain visual impairment, but I have never ever felt from any of my colleagues, my superiors, that maybe I have some different working styles. So that is something very good, and it helps me becoming more independently on my own, take my own decisions without any intervention.
It is an organization that promotes work-life balance well. There's a lot to do with the leave policy, and there's a lot to do with the work timings at the organization as well.
Tata Steel employs some unique hiring approaches to engage and connect with diverse talent and to build Tata Steel as an employer of choice brand.
We very strongly believe in the kind of people that we have, starting from the selection so that we get the best of them. Post that, nurturing them, grooming them, allowing them to flower and bloom.
When you say workforce, I would actually look at workforce as in commercial teams who are present in the marketplace, and they are the ones who address the customer queries, and they are the face of Tata Steel in the marketplace. Plus, of course, our distributors and retailers who are spread around the country. So in the path 1, which is the classic products which customer buy, we are looking at challenging the current systems so that they are kept agile and the processes are kept up to date. And that's about in the current businesses. When it comes to the other path, which is new services and solutions, you have to work with the ecosystem and smart design processes which are much more smarter, which have not been done before. So that's the path which is less traveled. And workforce has to address both the paths. We keep the current systems agile and quick to react, and also design systems which are just good enough to make sure that we can put a Tata name on that product or service.
And this is what our approach is about people. We would like them to develop and become what world-class leaders, become the best experts in the field that they want to be. Now, for doing so, we also empower them so that they can experiment, they can do whatever they want to.
Tata Steel engages employees with a multitude of activities. Apart from celebrations and social gatherings, the company encourages dialogue with top management.
the changing demographic, like there is more younger crowd in the organization, there's more women in the organization, the demographics are already changing from what the traditional mindset people used to have in this organization. We are seeing more employee engagement activities. We are participating in many forward events, you can say. We are sponsoring many new initiatives across the organizations. We are picking talent from the topmost colleges of the country. And that's why I think as you get a mix and blend of better crowd, better younger generation, then the atmosphere as a whole is changing and it's making it more fun to be at work.
We have structured programs where we shape leaders, we help leaders to become more professional, more competent, and more leadership-like. And also we have programs which expand the breadth of people within the organization to look at newer things and try to do things in a newer way, and how to be more efficient and effective and bring value to the company and its stakeholders.
In terms of bringing out the best amongst people, and we have created a number of labs which we call as HR labs, where we're looking at that how people can get better experience. So this is a lab called User Experience Lab. We're looking at blue sky thinking in terms of blue sky lab, where we are looking at that what is the possibility which can be created in the organization.
In this lab, we are trying to experiment and explore beyond the obvious HR functions to craft a future-ready organization. In this lab, we are questioning the current state and we try to frame a new HR organization which will think like business, which will act for business, and which will mean business.
We're looking at how we can be the role models in terms of the culture of the organization, how the culture should support, and it should be current, it should be contemporary, it should be catering to people who are new to the organization, the new generation, looking at the demography that is changing.
With ensuring overall employee development, the company also has policies to take care of employees' families. Tata Steel does not just focus on the present, but also envisions a future-ready company.
The future of the worker and workplace will be different compared to what we have seen in the past. With the onset of the entire digital revolution, with the adaptation of analytics, with the role of human judgment being different compared to in the past, I think this is a very exciting place and a very exciting industry as India grows to become a more developed country in the next decade and beyond. Steel is a very foundation industry in nation building, and yet has got its excitement as far as technology is concerned, markets are concerned, consumer is concerned, products is concerned, and therefore I think Tata Steel offers and provides a huge platform.
Over the years, Tata Steel has developed its policies in such a way that it has rightfully earned the status of being one of India's most coveted workplaces.
Once you enter Tata Steel, or once you work for Tata Steel, you actually grow in the Tata ecosystem. And if one has got the right talent and the abilities, it is a much wider landscape to demonstrate one's own wares. And I think this is a very unique proposition, and I could say that I've been an example of such cross movement within the Tata Group, and then come back to Tata Steel, which to me is like a second home.
For me, Tata Steel is a place where my dreams came true.
To me, Tata Steel just feels like home.
At Tata Steel, we also make tomorrow.
Tata Steel is my family.
Tata Steel is an emotion.
Tata Steel is happiness.
Tata Steel is full of opportunities.
Tata Steel for me is a way of life.
Tata Steel is rewarding.
A fascinating institution that you have to experience.
A company with a soul.
Tata Steel signifies different things to various employees.
This is a company wherein elephant can dance,
which is the first part. And the second part is it's a 100-year-old startup. That's what we are. And we do both the parts very nicely.
Well, it's a company which is resilient, a company which is in a tough industry, a company which has a soul, a company which has a heart, a company which is innovating, a company which is constantly reinventing itself. So I think you want a stable career, you have it. You want an exciting, disruptive career, you have it. It's a company where you join at the entry level and you can rise to the top, like all me and my predecessors have done.
We have Vidhi here, please, with us. I think we should wait for the jury. There's 2 jury members right now. Yeah, we have Mr. Sujit Sinha. We can wait for Mr. Anurag. Also, hello, sir. Welcome. So, sir has also joined us. Mr. Mukherjee is here.
I will change my description in that screen. I am Satish Tiwari, so I am there. I don't know. It appearing as chief mechanical maintenance. So
Yeah. No, that's okay. Shrikant sir, Tiwari sir, right? So we're just checking with Vidhi. Very soon she'll join us. Very soon we'll go with our presentations. So I would like to ask our jury members how their experience been with the presentations and taking out top 3. Would it be tough? Is it a tough call, or you know, we have clear winners lined up?
For me, it seems to be tough one. So we have to be in the. I don't know about others, but.
Mm-hmm. Yeah.
So far, so good. I would say so far, so good.
Okay.
I think 3 out of 6 or 7 is good, but it all depends on the rest 3.
Yeah.
Yeah. So Mr. Anurag Saxena has also joined us. Now let's move on with the participant. Hello, sir. Welcome back. So so Vidhi is here with us and we can start. Can we have Vidhi, please? So Vidhi is all set for the presentation. Hi, good afternoon.
Good afternoon, ma'am.
Good afternoon, Vidhi. So you're set for your presentation?
Yes, ma'am.
So are you nervous?
Not much.
Little bit.
Yeah.
Okay, over to you. Thank you. Best of luck.
Thank you. May I share the screen?
Yeah,
you can share the screen.
Yeah, is my screen visible? Ma'am, you are mute. Is my screen visible?
Yeah, it's
Yes,
visible,
yes.
but yeah.
Yeah, it's visible.
Okay.
Just have the presentations mode, huh? Full
Yeah,
presentation.
just have it in a slideshow mode. Yeah, that's okay.
That's fine.
Okay. So, good afternoon to one and all present here. My name is Vidhi Sachan and I'm from NIT Rourkela and I'm pursuing my BTech degree in Metallurgical and Materials Engineering domain. And today my presentation title is Reduction in Breakouts at Thin Slab Caster. So first of all, I feel very delighted to be a part of Top 10 in Women of Metal Season 6. And for this, I would thank Mr. Pranay Ranjan sir because without his guidance, it was not possible. And he shared a very good support system and time with me. So let me begin my presentation. So moving on to the first slide, it is the introduction and executive summary. So as my title suggests, slab caster. So first we need to know what is a slab caster. So slab caster is a caster which transforms the liquid steel into slabs of thickness of around 50 to 65 thick slabs because here we are discussing about thin slab casting. So a slab caster helps in casting the slabs. And if we see our topic, reduction in breakouts, so if we are making slabs, so there can be any breakouts, any sort of breakouts can occur. And to reduce that breakout, we'll be discussing how to reduce and how to avoid all those things. So in steel industry, there is a major setback if any breakout occurs. So if any breakout occurs and that can be of a major loss, not only in economical terms, but also as a safety health hazard. So in our presentation, we'll be discussing about breakouts in thin slab caster, its causes, detection, countermeasures, and some preventive measures. So first of all, let's take an overview of steel making process and about LD-3. So LD-3, why particularly LD-3? Because there are three types of LD converters which are of major use. And first one is for making billets, the second one of conventional slab casting, and the third one which we will be discussing, which is for thin slab casting. So the overview is here. In the blast furnace, after reduction of the iron oxide, we can see a slag layer floats above the iron ore, and that slag and the charge below it, we need to separate that. So from a nozzle below, we can separate the charge from the blast furnace, moving it on to the LD converter. And in LD converter, the steel is made basically by adding by deciding the concentration of carbon content, because there are different varieties of steel which we require. It may be a low carbon steel or a high carbon steel. So that will be decided in the LD converter, and in LD converter we put a vertically blast hot air inside it for making steel, and then further we transfer it to ladle furnace and then tundish, and then the casting part starts from vertical to making it horizontal by cooling it at a proper rate by using the chiller materials, and then finally rolling it for transportation and how can we better use it for the further process. So moving on to our next slide, we'll be having a brief introduction about the breakouts and analysis of the breakouts. So the breakouts, when the molten steel falls off, when it bleeds, like here a term red bolded I have written, that is bleeding, which basically means when the slab ruptures and the liquid molten metal falls off, and that is called bleeding. So the liquid molten metal bleeds from that. So this term will be used a lot. That's why I've just pointed it in a highlighted version. And the introduction about the breakouts, we can see the statistics shown on this slide. We can see that the number of breakouts, it is showing, the bar graph it is showing, there is no such downtrend. So we can definitely say we don't have a particular technique to reduce the breakouts, because we are not able to make it down inclined. Okay, because in 4 financial years we have discussed, and the 4 financial years there is no such downtrend. And also the types of breakout from the pie chart, if we see the maximum percentages of NMI breakout. So we can definitely say that we need to work upon NMI breakouts to reduce the total number of breakouts, as it contributes to the maximum percentage of breakouts in the total industry, steel making industry. So we'll be discussing about the major breakouts and also some minor breakouts, because these may they contribute lesser amount, but still they contribute. So moving on to the types of breakouts, our first breakout is sticker breakout. So sticker breakout is typically characterized by transverse rupture of slabs, and in this breakout, there is a when we make the slabs, okay, when we make the slabs and there is a breakout, we are talking about sticker breakout, and this breakout can occur when the slab sticks in the side shell of the copper plate and it ruptures into two. Means a local thin shell is formed and the which remains behind, and further it moves because the casting is going on, so there is some casting speed, so it moves forward, but still there are two locally thin shell formed. As we can see in the diagram, the yellow color diagram, we can see the molds are getting into rupturing into two parts. Why? Because they are sticking there and the other part is moving ahead. So that is a breakout which is called sticker breakout, that sticks into the shell, and that's why it's rupturing into two. So how can we detect it? It is the rise and fall of the thermocouple temperature. Thermocouple temperatures is like two wires stick to the charge and the copper plate. To measure the temperatures, it has various ranges. So here we can see there is a sudden rise and then a sudden fall. So by monitoring the thermocouple temperature, we can say that sticker breakout is happening if we see a peak in it. And the root cause can definitely be improper lubrication, because if lubrication is not proper, then only it is sticking in the side shell. That's why it is sticking and not able to move forward. And how can we prevent it? Because if both the shells move together, then breakout is not happening. So we can slow down the casting speed so that the healing can be quickly. The ruptured sticky shell can heal quickly. So how can we avoid it? How can we avoid the sticker breakout is like mold powder development, because mold powder is the most useful, or we can say it is the most key point where I'll be focusing more, because without mold powder I don't think the steel industry can work, because mold powder development is the utmost important thing in the whole making of slabs and casting of the slabs. So we need to develop mold powder, and there should be a fine tuning of mold oscillations so that the shells don't rupture and they move together, like they don't rupture, the healing is quick. So moving on to our next breakout, NMI breakout, which is the major breakout, it contributed 65%. So we really need to look into this breakout. So NMI breakout is non-metallic inclusions. It is some foreign materials which enter in the slabs, and it disrupts the homogeneity. It disturbs the mechanical properties and the desired type of steel we want. So how can we detect it? I have written early detection is not present at the current scenario, because NMI is the foreign materials, and foreign materials can be any foreign material. That range is wide, or we can say it is infinite. We don't know which material will come and what effect it will cause. So we cannot say that there is a particular technique and NMI will be avoided or it can be prevented. But we can definitely say that if like some X particle, we generally see X particle and it is having an inclusion in it. So we can look forward in a particular way, but we cannot completely just take that breakout off the whole scenario. So the root cause is like if we don't clean the steel equipments properly, or we don't do proper sealing, and some foreign materials enters and it disrupts the homogeneity of the slabs. And the countermeasures is we should check the taping practice, we should check the porous slag, because slag which is formed after the due to the mold powder, because it depends, if there is a porous slag then we can definitely say something is wrong, because after the whole procedure is done, the slag come out, and if we notice the slag, we can tell much about how the casting process is done before that. Because if there is a fine slag, if there is a normal fine slag, we can say that everything is fine, but if it is a porous slag, then we can definitely say that there is something wrong in the casting process earlier. How can we look forward to remove this? Not completely, as I said, but yes, we can definitely study about different models, like maybe there is sulfide impurity, we can say there is sulfide NMI is happening. So we can definitely study how the thermocouples behave in that, what are the heat flux signatures in that, and we can say if we notice this trend in the thermocouple, we can say that this material has entered, maybe sulfide or maybe any alumina or something can anything can enter. But we can say that if this NMI is contributing to the most, so we should study that model development, because that will only help us to eradicate the whole situation to a greater extent. So this is all about NMI breakout. Moving on to our next breakout, which is crack breakout. So this is a breakout in which crack occurs and the bleeding happens. It is very easy, like the slab is on the process of casting, and the crack has occurred and the liquid molten metal falls off. That means it bleeds. So we can say that crack breakout has occurred. And how can we detect it? It is a temperature drop in thermocouple. It is just a drop. If we remember like sticker breakout, there also we discussed about the thermocouple thing, and in that it was a peak, like it was a rise and then a fall. But in crack breakout, it is just a temperature drop. So this difference we can say in thermocouples tells us a lot, like what has happened. So this is how we can detect a crack breakout. And root cause is improper lubrication, because lubrication is of utmost importance, and not everywhere we are writing as improper lubrication, but yes, it is definitely required that lubrication should be good, because mold powder decides a lot. Mold powder can be of different compositions. It can be of glassy form, it can be of crystalline form, depending upon this how we are wanting the steel to be. And the countermeasure can be we should apply the superheat if necessary. We should see if the heat is required, or we should see if the cooling is done properly or not. The chiller materials are proper or not. We should know that if it is not cooling down properly, it is not coming to its solid state at the correct time, so it can bleed, because the temperature is too high and the cooling temperature and the process of cooling can be also different types. It requires a higher rate of cooling or a lower rate of cooling. That depends on the steel, and we need to look at that thing, the mold lubrication, the superheat thing, to avoid the crack breakout. And how can we move forward to this breakout to remove, not completely, but yes, we can generate the alarm on the basis of heat flux and thermocouple temperature. Like if it is showing this trend, so it will give a beep alarm, so we know that there is something wrong and we can just check before something bigger happens. And the mold level set point, which means like it is fixed up to 75%, you should fill it. You cannot fill it 100% because that will be like that can be harmful or dangerous also. So it is fixed like 75% is filled, but if you continuously use it, the erosion will happen. So we have to reduce that level set point to less than 75% because we cannot always use it at 75% capacity. So we need to look in that also, like how to reduce and when to reduce and how much to reduce. So moving on to our next breakout, which is startup breakout. Startup breakout is when it is like the discussion will be around the dummy bar which we use, like before pouring the liquid metal steel to the directly casting it like into the mold. First we put it in a dummy bar and then we move it forward. So this is the procedure, and when we move it forward, and in that procedure, like moving from dummy bar to the mold, and any breakout is occurring, that can be a startup breakout. It can be visually inspected, like it can be visually seen if there is some bleeding occurring or the cooling is not done properly, so liquid molten metal may flow out or anything can happen. So the root cause can be pouring, like from one vessel to another. We need to be precise, like how to pour it and how to just chill the material, how to just solidify the steel, because that is of the most importance when you are putting from one vessel to another. It should not fall off or it should not fall at a wrong place. It should be properly aligned, and it should be like the speed between the both should be with respect to each other. It should be proper, like the speed required. Like if it is moving ahead or if it is not at proper alignment, it can fall off due to the temperature change. That's what the chiller material we discussed about. So how can we move forward is mistake proofing can be done to eliminate improper mold separation or sealing. The sealing should be proper, the alignment should be proper, and we should check if the chiller materials used are properly used at proper time or not. So moving on to our last breakout, not the least, but we cannot discuss all the breakouts. So this is the last breakout we will be discussing in this presentation, which is hydrogen induced breakout. Hydrogen induced breakout, as the name suggests, is due to the hydrogen gas, or we can say excess of hydrogen gas, because excess of hydrogen gas will form the blistering of metal. Due to the high concentration of hydrogen, the blistering can occur, and which will lead to damage, which will eventually lead to this hydrogen induced breakout. We can detect it by again thermocouple temperature readings. It will be like it will become constant at the lowest reading. It will not be like constantly going down or constantly at a higher reading. It will be constant at the lower reading. So we can detect it by seeing the thermography. And the second point which I've written in detection is a test which is WFMPI, which is not actually the detection before. Like we cannot detect it before by using this test. It is after we can detect it. Like the slabs have come out and now we can detect is there a hydrogen induced breakout in that or not. So it is a after detection, and initially we can detect it by the thermography and studying of thermocouple temperatures. So the root cause can be improper lubrication, just like the sticker breakout due to hydrogen gas it is happening, but a local thin shell is forming in the copper plate, and it is rupturing into two due to the more concentration of hydrogen. And we can reduce it by using less amount of hydrogen materials required, because if low hydrogen electrodes are used, then low hydrogen will be there in the charge, and low hydrogen is there, so hydrogen induced breakout will be in lesser limit. So how can we look forward is we can early detection can be done, like we generate an alarm by seeing the thermocouple temperature, or we prevent using of more hydrogen products, because hydrogen gas, if more used, then only it will lead to hydrogen induced breakout. So main thing is signature thermocouples, and second thing is the lesser usage of hydrogen required products. So moving on to our final summary and a way forward in a general, or we can say a general way forward to all the breakouts. So if we see the overview, we can say that the most important thing was mold powder development, because without mold powder development, we cannot cast a steel according to the requirements. And second was the thermocouple, or we can say heat flux temperatures. And third one, the improper cooling. The chiller materials, they have a very great importance. If the chilling is not done properly, then it can lead to breakouts at any stage, because it needs to be solidified at the time which is required. And the model development, as we studied in as we discussed in the NMI breakouts, model development with respect to different materials or different NMI which can happen, because NMI is having a greatest percentage in overall breakouts. So we need to focus on NMI a little bit more so that the problem is lesser. So these are the 4 points, which is the basic mold powder development, heat flux, thermocouple, like model development, and the chiller materials we use. So this was about my presentation on my topic, and thank you for sharing your time with me. And now I'm open to questions. Thank you.
So, Vicky, good afternoon. This is Anurag.
Yes, sir.
I think you use word thermocouple many times.
Yes, sir.
Thermocouple works on one of the principle of physics. Can you name?
Sir,
12th physics.
Sir?
It is physics of 12th standard.
Sir, we use thermocouples to detect temperature, basically, like the temperature range.
Okay, so I am asking on which principle it works. So I am telling you the effect, Seebeck effect. What is the Seebeck effect?
Sir, you are not clear to me.
I am asking that thermocouple works on Seebeck effect. What is Seebeck effect?
Oh, Seebeck effect. Sir, I don't know about this.
The thing you told that this mold oscillation system can also, if there is a problem in mold oscillation system, can also cause the breakout.
Yes, sir.
What is mold oscillation?
Sir, mold oscillation is when we pour the liquid metal into the mold to cast it. So there is a, like, they move forward with a speed, like that speed, and the chiller materials are sprayed from the side ending. So that is a oscillation, like when we move the mold and it gets solidifies, and then finally it is sent to rolling and the further procedure.
Again, it's not clear. What is mold oscillation?
Sir, it is the like oscillations of the mold, like the casting speed and
How these oscillations are done? The mold?
sir, the oscillations means the molds move forward, and that is the oscillation.
Have you?
Machinery.
Because of oscillation, mold moves forward. Or mold moves forward, it causes oscillation.
Sir, the mold moves forward and that causes oscillation.
That causes oscillation. Are you sure?
Yes.
So how mold will move without any force?
No, sir. Like it will be moving, right, and that will cause the oscillation.
Okay.
The molds.
So, yeah, have you visited? Have you seen the caster or just online?
Sir, not practically, like not with
Okay.
naked eyes. I've seen, but I've read about. Yeah.
Okay, okay. Thank you, Vidhi.
Thank you.
That's all from my side.
Hi, Vidhi. Good afternoon. Satish Tiwari this side.
Good afternoon, sir.
So, Vidhi, you talked about superheat.
Yes, sir.
What is superheat?
Sir, it is the amount of heat which we require. Like it is not always the same amount of heat we require. So that was just to like just to say the amount of heat.
So that is amount of heat means what unit?
Sir, joules. like the heat energy or maybe the temperature, how much temperature we require.
Why it is called superheat?
Sir, superheat, exactly term, I cannot say why it is called superheat, but the temperatures, up and downs of temperatures.
You mean temperature fluctuation?
Yes, sir.
Okay. Okay, thanks. Thank you. That's all.
Thank you, sir.
Yeah, Vidhi, good afternoon. Surajit here.
Good afternoon, sir.
Yeah, you did not talk about casting speed. In fact, I was looking in your presentation. Is casting speed not an important factor? And then what Mr. Anurag Saxena was talking about, you talked about dummy bar. So in when the first casting is started, the dummy bar is withdrawn from it's in a vertical position, and the mold oscillates on a eccentric motor, and there is a casting speed. I think these three factors are very important. I think somewhere in your presentation that should have featured. So, any idea that mold is made of what material?
Sir, the mold. Sir, I think it is of copper.
Good. Okay. Thank you. Thank you.
Thank you, sir.
So it's a little unrelated question, Vidhi. Good afternoon.
Good
That
afternoon.
while you are preparing for it, and so did any point of time you really think that you should visit the plant, get a overview of the clusters, and it's all about a theoretical exercise that you are presenting.
Yes,
Okay,
sir.
so
I think
did any point
I
of time
thought,
it stuck to your mind?
yes, sir. Definitely. I thought like if I would have seen that in real, so I would have understood it properly. Like just seeing videos or
But has
reading.
anyone stopped you? Has you approached your mentor? Has anyone stopped you for not coming and having a look at the clusters and everything?
No, sir. Nobody stopped me. Definitely, and even my mentor asked like if you are going to visit our plant or not. But at that time, like initially the holidays were going on, but that was the initial stage of my project going on. Then the college started. So right now also I am in campus only. So I think maybe during internship period I will be able to learn more of it.
I think Nidhi, you can visit your town where you are studying. Rourkela also has a caster. In fact, they are also flat producers. So
Yes, sir. Yes, sir. I'm thinking like Rourkela steel plant that is also near. I'll definitely
may
visit.
not be a TSCR, but you can certainly
Because
view.
Yeah.
Yes, boss. Go ahead.
So the last point, Nidhi, for me is, you have mentioned summary and way forward. No, that's a slide on the screen now. Okay.
Yes, sir.
And you have mentioned lot of things about in terms of improper cooling flow, heat flux and temperature signatures. So all these things must have a KPI. If you are not mentioning that, what is the ideal parameter? What's the parameter through which it works? It's only in words, written in words. Because if somebody has to work on it, people cannot work because it's all literature. You understand what I said?
Yes,
Therefore,
sir.
whenever you are recommending something summary and way forward, the fundamental thing has to be there that what is your recommendation? Because if you do not measure anything, it cannot be improved. That's in a very simple term. Okay, so all the best, Nidhi. I think a lot of work has to be done, huh?
Yes, sir.
Thank you.
Thank you, sir.
Thank you. Thank you so much, Vidhi, for the presentation. And now we have our next participant amongst us, Priyanka Kumari. Vidhi, you can exit. Yeah, thank you so much. And now we have our next participant with us, Priyanka Kumari. And then after that, there is one participant left, Priya Kumari. And after that, we'll move on with our results. Can we have Priyanka here, please? Hi, Priyanka. How are you?
Hi, ma'am. I'm fine.
Fine. You seem to be a little nervous. Are you?
No, actually, I have stopped my fan and I'm sweating. Like it was causing sound disturbance. That's why.
Oh, okay. That. But you don't have to worry. Jury members are quite amicable with all their participants. So whatever is there in your mind, please present it. Thank you so much. Over to you.
Noise also. We are used to noise also. Noise. You can switch on the fan, Priyanka.
Yeah, you can switch on the fan.
Like
It's
I'm
fine?
fine. I'm fit.
Okay. Okay, over to you, Vidhi. You can start with your presentation.
Done. Ma'am, my screen is visible, right? Ma'am, is my screen visible?
Yes, yes.
Yes, it is visible.
Okay, sure. Fine, sir. Okay. So, good morning, everyone. I am Priyanka Kumari, a junior year student currently pursuing metallurgical and materials engineering at IIT Patna. Today, I'm going to talk about the reduction of nitrogen pickup at ladle furnace. I have done this case study under the guidance of Ms. Shivani Agarwal. To begin with, I would like to give a quick overview of the steel making process. The entire steel making process of reducing the carbon content from high weight percentage to low weight percentage involves various steps, starting from hot metal input to the final output. Let me direct your attention towards the fourth and the fifth step, where the online purging is done and the hot metal is further sent for ladle treatment in order to ensure the homogeneity of the bath composition and the temperature. While this transfer, an increase in the nitrogen content of the liquid metal is observed. And the steps, few of these steps which are carried out in the ladle furnace also account for the increase of nitrogen content in the liquid metal. So, so this is where the nitrogen pickup comes into picture. As we know that the dissolution of nitrogen in the liquid steel is driven by both kinetic as well as thermodynamic factors. It is an endothermic reaction and hence follows Henry and also follows Henry's law and follows Henry's law, and hence it increases with increase in temperature and the pressure of the gas over the liquid metal, and the partial pressure, I would say, partial pressure of the gas over the liquid metal. And in the kinetic mechanism, various steps occurs, out of which the rate determining step is the step in which the N2 molecules get dissociated into nitrogen atoms. Okay, so why are we talking about controlling the amount of nitrogen in the liquid steel? So let us talk about the financial impact first. Heat treatment in the entire manufacturing cycle has utmost importance, but generating heat was never at an easy cost. All the steel industries around the world are gradually trying to improve the methods of heating the substance. Let me bring forward to you the scenario of LD3 shop of Tata Steel, where in the financial year 2022, 90 heats, like the 90 heats were diverted due to off in chemistry as in total, and out of which more than 17 heats were diverted, especially due to off in nitrogen. So it creates a huge impact over the entire steel industry. So I think that discussing about this topic is an important thing. So let me discuss the impact of nitrogen on the quality of the steel too. Though the presence of nitrogen in the steel enhances the properties like hardness and yield strength and corrosion resistance, we cannot ignore the disadvantages of it being present in the steel in higher amounts, since it leads to decrease in toughness, makes the material more brittle and porous, and also causes strain aging. So considering these factors, I can come to a conclusion that nitrogen control in steel is very important to achieve its chemistry. Thus, it is required to know the probable reasons for the pickup and reduce the same. While discussing with my mentor and the literature survey, I found out that the nitrogen pickup in ladle furnace occurs mainly due to arcing, holding time, purging, and addition of charged materials, exposure of liquid metal to the atmosphere, and the slag. which I'll discuss in detail in further slides. Until then, let me bring your attention towards the nitrogen content at different stations of LD3 shop of Tata Steel. From the graph, we can see that the nitrogen content has increased nearly by 20% when the liquid metal comes out of the OLP station and goes into the LF. And about 13% when it further comes out of the ladle furnace. So now let us discuss how nitrogen pickup occurs during arcing and how can we prevent this. The main reason for the nitrogen absorption during arcing is the formation of a concave surface by arcing and the movement of N2 molecules from the gas phase to the boundary layer. And in the next step, what happens is the N2 molecules get dissociated into nitrogen atoms, and the absorption of nitrogen occurs in the molten steel through the exposed area. It has been noticed that the nitrogen pickup increases with arcing time. So we should try to minimize the duration of the arcing in order to reduce the nitrogen pickup. Another process that affects the nitrogen content in the liquid steel is purging, which is done in order to reduce the sulfur content of the liquid metal. It leads to formation of an open eye, also known as a slag eye or the spout eye, through which the absorption of nitrogen occurs in the atmosphere. The factors that favor the nitrogen pickup during purging include longer stirring time, high gas flow rate, the thin slag layer, and lower concentration of oxygen and sulfur, and also the presence of impurities in the purging gas. And the nitrogen pickup also increases with increase in the treatment duration. So we should try to, because it is because the formation of the spout eye becomes easier. So we should try to minimize the duration of treatment duration also. And the addition of various alloys also account for the increase in nitrogen in the liquid metal. So these are called the charge materials, which are added as an it contains nitrogen as an impurity. So the charge materials which are added include the calcine petroleum gas, that is CPC, which is having 0.05 weight% of nitrogen, and Mn metal flakes, that is having 0.01% of weight% of nitrogen, and the FeMn medium carbon alloys having 0.05% of weight% of nitrogen. Atmospheric factors also play an important role in nitrogen pickup in the ladle furnace to a greater extent, I would say. And it has been observed that the nitrogen pickup decreases with increase in the sulfur drop. And because oxygen and nitrogen are surface active substances, it is extremely easy for the molten steel to absorb nitrogen when the concentration of oxygen in the molten steel is extremely low. Argon gas is used for purging or stirring. Argon gas is used for stirring, and in order to strengthen the reaction, which causes exposure of the molten steel to the atmosphere, resulting in nitrogen absorption. Slag also plays an important role in the nitrogen pickup. When the slag layer is very thin, it causes nitrogen from the atmosphere to dissolve in the slag. During the bottom stirring, what happens is the gas which is used for which is purged, it comes out of the it comes through the whole liquid metal, and it forms some cracks in the slag, and due to those cracks, what happens is the nitrogen from the atmosphere gets absorbed into the liquid metal. So we should try to make the slag layer as thicker as possible. Also, since my study was mainly based on the LD3 shop of Tata Steel, I have here shown a comparison between the LD3 comparison of LD3 with LD2 as well as the Tata Steel Kalinganagar plant using box plots. It is clearly visible from the data that LD3 is operating at higher nitrogen content as compared to the other shops. Also, during my literature survey, I tried to get an idea about what measures the other steel making firms are using in order to control the nitrogen pickup in the liquid steel. So I found that the Nippon Steel is using CaCO3, and ArcelorMittal is using 100% DRI method for N2 removal. And similarly, the JSW is also using like Buckingham PI theorem, something like that, to reduce the nitrogen pickup. So now coming on to the action plans which can be used to prevent the nitrogen pickup in the ladle furnace. So as we discussed earlier, how the slag plays an important role in nitrogen pickup. So looking into this problem becomes more important. To prevent the exposure of the foaming layer with the atmosphere, the slag should be made of appropriate thickness, as I discussed earlier also. Since the nitrogen is a surface active substance, if the exposed area would be lesser, the absorption of nitrogen would also be lesser. And the second measure can be to reduce the rate of the blowing gas per ton and to do optimal purging instead of doing vigorous purging. The nitrogen increasing in the molten steel increases dramatically if we blow the gas at a more than an optimum value, that is 100 nanometer cube per minute. If the blowing gas rate is more than that, the nitrogen pickup increases drastically. So an ideal blowing rate will lead to optimal purging and hence reducing the nitrogen pickup by reducing the chance of formation of slag I. So it should be made sure that the LF refining blowing gas per ton should not increase that required value. Another measure can be taken by using low nitrogen alloys. In every steel grade, the ferromanganese or the ferrosilicon alloys are added in order to adjust the composition. From the data given to me, I tried to find out that the grades of steel which are higher FeSi addition grades like Se110, SA139, and should be used instead of grades like SA103, SA154, SF109, which contains more nitrogen as an impurity, as it can be seen from the graph. And the next measure can be to seal the ladle tightly throughout the whole process so as to reduce the contact between the liquid metal and the atmosphere. And the ladle lids that I have shown, one of the ladle lid I have shown in the picture, this should be used throughout the whole process. Also, to reduce the sulfur content in the liquid steel, purging is done manually, which reduces the temperature of the liquid metal by almost 20 to 30 degrees Celsius. Then to maintain the chemistry, the liquid steel needs to be heated again by arcing and hence exposing the surface of the molten steel to the atmosphere again, which is the ultimate cause of the nitrogen pickup. So we can think of using a model which can control the operations of purging as well as the alloy addition and make the slag appropriate by achieving the right chemistry for sending the liquid metal for further casting operations. And this would really be helpful for the controllers of the ladle operations, and it will of course be less time consuming. So at last, I would like to thank Tata Steel for giving me this opportunity, and this case study has exposed me to the actual working of the steel industry and has intrigued me to explore it more in the coming future. And also, I'd like to thank my professors at IIT Patna, Dr. Anup Kumar Keshri and Dr. B.B. Agrawal.
Priyanka, this is Satish Tiwari. Sorry, Surjit, you are asking? You can go ahead.
No, so I think couple of points for me. I think if you go back to your original slide, if you just go back to the first or second slides.
Yes, sir.
Not this one, the next one. Sorry, you have talked about the number of 7, 8, 10, 12, no, those numbers. There's a slide.
Is it this?
Now next. Next. Yeah, I think this one is also similar. Yeah, anyway, so if you look at, there are process parameters, there are the material additives. There are two ways, nitrogen is actually getting added. If you are not maintaining the right process parameters or you are not putting the right material that you are sort of addressing. Did you also, for everything there is a cost to it. You can get nitrogen free, medium carbon, you can get nitrogen free, everything. So if you have to really balance between these two, that's what, somebody has to do a Pareto analysis to understand that which is vital few. you cannot control everything, because if you want to control everything, there's a very costly process, steel making process. So,
Yes, sir.
do you have any idea what is the easiest to control and what is the difficult to control between whatever you have mentioned so far?
Yes, so like a difficult one, I would say the addition of these alloys. Like earlier, I used to think that these alloys are so cheap, like 500. And I asked my mentor that how much the MN alloys cost. She told me that 550 rupees per ton. Then I said it's very less amount. We are getting 1 ton of these alloy in only 550 rupees. But she told me that the amount of these alloys which are added is extremely high. Like I also talked about the amount of heat that get wasted due to off in nitrogen. It was around 17%, 17 heats here in the LD3 shop. So if 17 heats are getting lost, then one heat corresponds to 160 tons. So 17 into 160, these many tons are getting wasted, and out of in that we are adding like more than 100 tons. We are more than 20 tons. We are adding those 550 tons of alloy, rupees cost of alloy. So I think it's one of the difficult thing to maintain, adding of these alloys. And in LD3 we use instead of these CPC, we use GPC, that is galvanized petroleum coke, and that is having lesser amount of nitrogen content, I think. So that can also be possible. And easiest one I would say is this. Sir, covering the ladle during the entire process. Like we only need one ladle lid. It will reduce the our liquid metal from the atmosphere also, and a lesser amount of heat will also be lost. Like since it is covered, we don't need to heat it more. As I said that 20 to 30-degree temperature drops when we purge the liquid metal. So using the ladle lid would be more efficient, I would say.
Okay, so
Not only during casting. Like I heard that during casting it is done. We should do it during the whole process.
No, so Priyanka, I think I was actually looking for a different response in the sense that, for as I said, everything has a cost, okay? And so I am not going by the cost of refined alloys or whatever. But if you have to look at, you have 1,000 tons or 500 tons, but these 500 tons have been contributed by many factors, okay? It's not by contributed by one factor. So did you do an analysis that what has actually contributed 1,000 tons? How much is 500 tons is because of alloys? How it is something because of shielding of ladle? Something is because of another reason. So did you do some analysis like this?
Yes, sir. Mostly the nitrogen content was increasing just because of exposing the exposure of the our liquid metal to the atmosphere. Like it is the main reason due to which the nitrogen is coming into our liquid metal.
So what is the action plan on this? If we say that your arcing time is much more, and where the exposure is much more to the because nitrogen is picked up from the normal atmosphere, no? So that is not visible. I didn't see in your presentation. By sealing the ladle, you will not have it. Okay, that is not a solution for it. So how do somebody say that this is my arcing time? Sorry, carry on.
Like one more solution, I would like to say that the arcing duration, we should not increase it very much. Like we can do a little bit of arcing and then check the composition whether the right chemistry is achieved or not. Then we can again do purging. Like optimal purging or stirring should be done. We cannot continue doing it and checking at last what is the composition. We should check the composition after a certain interval of time.
Okay. No, so I think in 21st century, more or less is not a solution to everything. There must be a very defined KPIs, KPMs, that this much of time I must do the arcing. After that, I will test. So with your mentorship, whoever is your mentor, did you discuss all these points? That real KPMs, KPIs of the process?
So one more thing, like no, like I discussed about the cost and all addition of those alloys, how much those alloys cost, and do we really use these lids in the plant actually? So and one more thing I would like to suggest is that we can use a model like which can monitor all the what is the concentration of this alloy, what is the concentration of like what should be the purging duration and all. It should monitor that, and seeing that we can like stop the process when the right chemistry is achieved or something.
Okay, thank you, Priyanka. Thank you.
Yeah, Priyanka, good afternoon. Satish Tiwari this side.
Good afternoon, sir.
You discussed about Henry's law.
Yes, sir.
What is that?
So it's that the solubility is directly proportional to the mole fraction of the gas present.
Solubility is proportional to
The like the mole fraction, I would say, or the partial pressure.
right. Thanks. Thanks, Priyanka. That's all.
Thank you.
Yeah, Priyanka, good afternoon. Surajit here.
Good afternoon, sir.
I see there's a lot of detailed work, obviously helped by your mentor. So, and you have concentrated on LD3 TSCR. So, across your study, did you come across the word sequence break? Because if you are aware, then probably most of the issues of nitrogen pickup, which I understand, could be from that only. That if there is a sequence break in caster, so if you have heard it, then probably would have been able to make your judgments or answers more convincing. So we didn't, in fact, I didn't get that word because that is very important, because in this kind of a shop, sequence is very important, because finally the steel which is molten is casted into a shape. So
Yes,
you
sir.
have to,
Actually,
yeah.
my stud like I was given this case study like only to study the effects which lead to increase in the nitrogen content at ladle furnace. So I was like restrained to the studying about ladle only. Like
Yeah,
I asked
yeah. So
to the
that
same.
at the ladle furnace, the ladle waits because the downstream units might be getting held up. So that is what the sequence is of the sequence of a caster. So I maybe it is a bit detailed thing, but anyway, whatever you have done it, good. So and I was happy that you have tried to put that benchmarking thing where people are talking about DRI to produce steel and all. So in a whole, I think it is okay, but I think you should have included some of these other parts to make your case much more stronger. Thank you.
Okay, sir. The
Thank you.
caster part, right?
Yeah. Why it actually happens? I think if you had asked your mentor, I mean, you can check this in theoretical knowledge or there. Anyway, thank you. But anyway, it's a good presentation. At least you brought in a lot of data, as Mr. Stishendu was talking. I think at least KPIs, graphs. Obviously, these are from the plants, but you've been able to. So I can see some your box plots are also there.
Yes,
So
sir. I asked for the data to the my mentor. She provided
thank
me
you.
with everything.
Thank you.
Thank you, sir. Should I leave the meeting?
Yeah, thank you so much. So, are we done with the questions for Priyanka?
Yes, I think so.
Okay.
Thank you,
All right.
Priyanka. All the best.
Thank you, Priyanka. You can exit this meeting. And now we move on with our next participant, that is Priya Kumari. Can we have Priya Kumari here, please? Priya Kumari is the last participant, and after that, we move with our further proceedings. We have Priya Kumari with us. Hi, Priya.
Hello, ma'am.
Yeah.
Ma'am, shall I start sharing my screen?
Yes, what?
Shall I start sharing my screen?
Yes, you can, and you have to be a little louder.
All right, ma'am.
Yeah, a little louder and clearer. Thank you. Best of luck.
Good afternoon, everyone. My name is Priya Kumari. I'm pursuing Bachelor of Technology in Chemical Engineering at IIT ISM Dhanbad. My presentation title is Improving the Efficiency of Distillation Column through Process Optimization. And this was done under my mentor, Indranil Kundusan. Now let's have a brief outlay of what I'm going to discuss in the presentation. First, I'll be introducing the distillation columns. Then I'll be doing the efficiency analysis of the distillation column at Tata Steel, the factors affecting or influencing the distillation column efficiencies. We'll be looking into some of the problems faced by the industry and looking forward to the possible solutions and workarounds, and finally the future prospects to improve the existing efficiency. So let's move on to the distillation column. Now, column are of has utmost importance in separation technology. Undoubtedly, they are the undisputed king of industrial separation process. So, what is a distillation column? A distillation column is an essential item which is used in separation of liquid mixture into its component parts or fractions, and it is based on the principle of difference in volatilities. Now, coal is converted into coke in the coke oven plant. Now, the raw coke oven gas consists of many impurities like coal, tar, hydrogen sulfide, ammonia, naphthalene, and benzol, which needs to be removed before it could be utilized again. That is, the coke oven gas could be reutilized as a fuel within the plant. Now, there are three different types of distillation column utilized in the byproduct plants for removal of unwanted substances. First is deacidifier and ammonia stripper, followed by naphthalene distillation unit. Now, in the deacidifier and ammonia stripper, hydrogen sulfide and ammonia compounds are removed from the enriched scrubbing liquor, and in the naphthalene distillation unit, the rich oil which has absorbed the naphthalene is steam stripped in the naphthalene stripper. Now, in the right hand side, we can see the composition of the coke oven gas. We can see that most of the hydrogen sulfide and ammonia is absorbed, as the outlet composition of H2S and NH3 in the coke oven gas is less. So let's move on to the efficiency analysis of the distillation column, as I have already mentioned. Now, we know that in a tray type distillation column, vapor liquid contact occurs on the tray, and there is heat and mass transfer occurring. Now, the heat and mass transfer which is occurring is not ideal, and there is a deviation from such vapor liquid equilibrium, which is termed as state efficiency. In the following study, I have focused on the ammonia removal efficiency in the case of ammonia stripper, hydrogen sulfide removal efficiency in deacidifier, and naphthalene removal in naphthalene stripper. Now, the following methods that could be implemented to determine the column efficiency is we can compare the performance data from an ideal industrial column. We can also go about scaling up of data obtained from laboratory, or we can use some empirical efficiency model like the O-kernels correlation, or we can go about using the Murphy's efficiency, which is quite popular and is usually used. Now, let's have a look at the average efficiency of the columns. The deacidifier removal efficiency for hydrogen sulfide is recorded as 43.49%, and for ammonia it is 34.46%. Ammonia stripper records a very high efficiency, that is 99.56%, and naphthalene distillation unit records a very low efficiency of 20%. Now, if we look at the graph for naphthalene distillation unit, we can easily see that 20% remains almost constant throughout the days, whereas in the case of deacidifier there are fluctuations, as we can see, and in case of ammonia stripper it remains above 99.5% for most of the time. Now let's look at the factors which influences the efficiency of distillation column. First is feed composition, the state of the feed, the composition of the feed, and the trace elements that are present in the feed affect the vapor liquid equilibrium of the liquid mixtures. Then the operating condition. there are the feed temperature changes which affects the efficiency. Then there is changing the steam rate of deacidifier as well as an ammonia stripper, and also the pressure condition which affects the efficiency of distillation column. Now, internal liquid and fluid flow conditions, there could be foaming, entrainment, weeping, dumping of flooding, which also affects the efficiency. State of the trays. Now, most of the efficiency also depends on the vapor liquid condition and the tray conditions. Column diameter. Vapor flow is dependent on the column diameter, as column diameter is largely responsible for vapor flow velocity. Now, I've done a correlation of parameters which influences the ammonia concentration in the lean liquor. In the first figure, we can see that sodium hydroxide, which is utilized in ammonia stripper, shows some correlation with the lean liquor ammonia concentration, which is measured in ppm. Similarly, in the right-hand side, we can see that the ammonia stripper top temperature shows inverse relationship with the lean liquor ammonia concentration in ppm. There are some other correlations which are plotted with the lean liquor temperature, the wastewater average pH, and the lean liquor feed rate, as well as with stripped water temperature. Now let's move on to the first problem which the distillation column faces in. Now, excessive pressure control scheme in deacidifier. Since there are fluctuation in the feeds, there are sometimes increase in the ammonia composition in the feed. Now, this results in the column pressure rising rapidly, which becomes very unstable in the real system and very difficult to control. Now, this usually the column pressure is controlled by manipulation of the vapor rate, and this is done by adjusting the feed flow rate or the steam rate. But this leads to other problems as such as entrainment and maldistribution. Now, we can also manipulate the feed temperature to provide an alternative method, but this will lead to increased energy consumption and a long time delay to activate control action since there is a large feed quantity of about 80,000 kg per hour. As we can see in the figure that if there is an increase in the pressure, there is also an increase in the steam consumption. Similarly, on the right-hand side, there are unusual fluctuations in the deacidified top pressure, which shows that the excessive pressure control. And here are the plots of the malfunctions due to upsurge in pressure. Now let's look at this solution to solve this problem. Now first, let's understand what's happening when there is an increase in ammonia. So whenever there's an increase in ammonia composition in the feed, heat generation takes place, which causes an increase in the vapor load in the column. Now this increase in vapor load causes a rapid rise in the column pressure. What we can do is we can use a pump around the side cooler, which allows us to control the column pressure by reducing the vapor load. And also it will reduce the heavy duty of the overhead condenser, and also, as I've mentioned, the vapor loading in the steam distillation. In the adjacent figure, I have plotted, the results of the dynamic simulations of the proposed control scheme is plotted. And we can see that the column pressure is properly controlled, and it also provides a fast control action for abrupt increase of the top pressure in the deacidifier. Now, let's move on to the naphthalene distillation unit. As I've already told that naphthalene distillation unit records a very low efficiency, that is 20%. So let's understand that what's happening in this case. Now, there is wash oil, which is used in the absorption and stripping of the naphthalene. This wash oil undergoes several heating and cooling cycles. And due to this, the life cycle of the wash oil is affected. Now, there are few factors on which the wash oil's life cycle depends, that is the viscosity, specific gravity, and initial boiling point of the wash oil. Now, there are some other factors which should be taken into account, which could be utilized to understand why NDU is recording such low efficiency. So first is operation condition of distillation column. There is less lean oil flow from NDU back to naphthalene scrubber, that is half of design specified. Now, lean oil inlet temperature or naphthalene absorbability. Since we all know that absorption is an exothermic reaction, if there is an increase in temperature, there would be a decrease in absorbability. So this is one of the cause. Secondly, we have the effect of lean oil inlet temperature on composition of the washer. Now, whenever there's an increase or there is a high temperature, there is polymerization, which leads to formation of chemicals like methyl naphthalene and acetylene in the wash oil. This hinders the absorbability of naphthalene. Similarly, the effect of high moisture content in the wash oil. There is ingress of water in wash oil, which leads to damage in shells and frequent breakdowns, and high moisture in wash oil causes leakages in shell. Let's look at the recommendations. There should be periodical inspection of the rich oils to control acetylene and methyl naphthalene content in the oil. Secondly, there should be maintenance of optimum temperature of 40 degrees Celsius in wash oil This is good enough for the absorbability of 3.1 kg of naphthalene per kg of water. There should be testing of water content in the with the help of kits to accurately measure the ingress of water in the wash oil. Now let's move on to the second problem. Now distillation column malfunctions. Now the plant performance depends on the extent of the ability of the equipment to function as intended. Now there are deviations and there are defective columns which lead to some serious consequences, and it may also lead to the decrease in the quality of the product. Thus, when a distillation column faces irregularities or deviations, it is necessary to find out exactly what is happening inside the column. There could be mechanical problems like displaced or damaged trays, or there could be corrosion, there could be level control problems. Some rate-related problems like entrainment weeping or unequal liquid levels on trays, process-related problems like maldistribution of vapor, liquid holdup due to plugging and fouling. Now, I have done a visual analysis of the malfunctions in operation in the distillation column present at the byproduct plant. There are equipment challenges that there is frequent vapor lock in the column, there is mug deposition, feed condition, it has excess ammonia in strip water, average wastewater temperature increased. Now, process problems like flooding, weeping, maldistribution of liquid and vapor, operation parameters like operation of distillation column on higher temperature and pressure than designed. Other problems include long downtime of tar and reduced efficiency in column and fluctuation in steam consumption. As it is shown in the right-hand side, the average wastewater temperature shows unusual fluctuations and high wastewater temperature. Similarly, there is excess sodium hydroxide consumption in the distillation tank. Also, there is unusual fluctuations in the deacidifier top temperature. Now, let's look out at a way to find out what is exactly happening inside the column and make necessary maintenance to cure these problems as stated. Now, malfunction data identification using gamma rays. What we can do is we can lower a gamma emitting source from one side of the distillation column and a detector from the other side. Depending on the quantity of the absorbed or transmitted gamma rays, it could be an indication of the actual quantity and nature of the material between the radioactive source and the detector. As you can see that a normal tray would show a graph something like this, and if there are some or the other deviation, like if there is light foaming or heavy foaming, it could easily be represented in the form of graphs, which could be further analyzed and proper maintenance work could be done to cure these trays. Now, let's look at the principle, the fundamental technique or the principle which it utilizes. As mentioned already, it is I is equals to I naught exponent of the factor given. Now, this is the principle, that is, in other words, we can say it is depending on the quantity of the absorbed or gamma rays which is absorbed by the detector. Let's look at the salient features of the gamma rays malfunction detection. This is a non-disruptive and non-invasive investigation. It has full length scanning capabilities. You do not need to remove any insulation from the outside of the distillation column, and it is applicable to all column sizes. Secondly, it is a computer aided data acquisition. Retrieval and analysis becomes very easy, and it utilizes small amount of sealed radioactive source with inbuilt radiological safety features. As I've already discussed the principle of measurement. Now, since we're using gamma rays, it is essential for us to have a knowledge about the radiological safety. Now, column scanning uses a sealed radioactive source which emits gamma radiation between 1000 to 10,000 times less activity than an X-ray. And the source folder is designed in such a way that exposures to the inspection team as well as the plant personnel do not exceed the permissible limits. So this could be utilized for the malfunction identification in the distillation columns. Now, let's have a look at the troubleshooting layout. As and when we encounter some irregularity or some deviations, it is essential for us to have a framework to go about solving the problem. First, we should identify what is the problem, if it's real or some or the other fluctuations, which usually happens in industry. The magnitude of the problem, we can go about classifying it as environment or it's with column. If it's with environment, we can go about finding whether it's with process unit or column control or operating conditions. If it's with column, whether it's with capacity or efficiency. If it's with capacity, then we should collect data on pressure drops versus rate. If it's with efficiency, we can go about finding the mass transfer parameters. And finally, we can make a feasible alternative and also make an economic evaluations of alternatives. Tray type recommendation. Now, bubble cap tray is utilized in all the three distillation column, but bubble cap tray has moderate capacity, moderate efficiency, and the cost is very high. Also, it has high fouling tendency. The alternative could be sea spray, which is high capacity, high efficiency. The pressure drop is moderate, and the cost is low as compared to valve tray, which is also popular in the industry, and bulk bubble cap tray also. I've shown a figure of the sea tray and the vapor flow in the sea tray. Now, let's have a look at the future prospects. That is, these were some of the shoot at site solutions. Let's look at some future solutions which could be implemented in the plant. Now, cyclic distillation technology. This is a major breakthrough in the distillation technology. Let's understand what is actually cyclic distillation. It utilizes separate phase movement. That is, in one operating cycles, there is the vapor flow period. That is, the thrust to the rising vapor prevents the liquid to downflow, and similarly, there is a liquid flow period. That is when the liquid flow down the column, first into the lock chambers and then moving to the tray below. So, let's understand the technological as well as the economical advantages. It is high tray efficiency, that is 140 to 200% Murphy efficiency. It is also said that one cyclic distillation is almost equivalent to three conventional distillation. It has reduced equipment cost. There is equipment productivity increased, reduced energy and requirements like 20 to 35 savings. Similarly, there is higher separation efficiency. And most importantly, there is enhanced process sustainability. That is less GST emissions due to low energy usage. And industrial scale up is also easy. Since we are moving to a completely new technology, it is essential for us to understand the possible pitfalls. Now, the possible pitfalls are it is difficult to apply to vacuum system, that is the pressure drops, it is difficult to apply in those systems, and similarly the performance enhancements critically depends on the separation of vapor liquid period. So these are the two important parameters which we should keep in mind before utilizing the cyclic distillation technology. Now another one could be controlled artificial irrigation in column. Now what this novel technique it utilizes is the liquid on the stage is recirculated back to the same stage by an artificial irrigation which uses a sparger using external pump. Now, since the liquid is sent back to the same stage, there is reduction in the reflux ratio, which ultimately gives us less energy requirement, and also the purity of the product can be altered just by opting for artificial irrigation. And it is also observed that there is enhancement in rectification irrespective of liquid distribution in the upper stages. The enhancement in rectification can be observed in terms of concentration of more volatile component increased in the distillation. So these were the few future prospects which could be utilized in the distillation column. Finally, I would like to thank Tata Steel for giving me an opportunity to work on this feature.
Good afternoon, Priya.
Good afternoon, sir.
This is Anurag. So you have described the process of ammonia stripping, distillation.
Yes, sir.
So tell me, if these processes are not controlled properly, what will be the impact on steel plant?
So these distillation columns are present in byproduct plant. If we do not control this properly, the wastewater which is sent out from the plant will have high content of ammonia, hydrogen sulfide, and other impurities as well, which will disturb the environment. Also, the coke oven gas which is reutilized in the plant needs to be properly cleaned before it is utilized again. So it is of utmost importance here.
So another question, if coke oven gas is not properly cleaned, then what will happen?
So if it's not properly cleaned, then if it is recirculated back, then there could be some problems. Like if it's used as a fuel, so I think we can encounter some problems wherever it's used.
Yeah, that's what I am asking. What type of problems will be there?
So since hydrogen sulfide and there are tar components also, it can lead to deposition of these substances. There could be tar deposition in the plant, which could hamper the equipment, and of course the downtime of the equipment could increase.
And what will happen to effluent? So what problems will be there? Let us say, will it impact the effluent treatment process?
So I do not. What is effluent treatment process?
You don't know effluent treatment. Okay. Thank you.
Thank you, sir. Thank you, sir.
So, do we have any more questions?
Yeah, nothing from me.
Okay. So, I would request all our jury members to please fill the evaluation sheets with Miss Komal Singh and Miss Vaishnavi Shankar. And Komal Singh's mail ID is komal.singh2@tatasteel.com. And Vaishnavi Shankar's mail ID is vaishnavi.shankar@tatasteel.com.
Can we discuss among ourselves for some time?
Yes, of course you can do that. And Priya, thank you so much for the presentation. You can exit the meeting.
Ma'am, I'm unable to. Can you please remove me from the meeting?
Yeah. So we are live now. Okay, once again, welcome back. So our judges are here, and obviously taking out the best three was quite tough. But as you all know that we have to take out top three winners. But all the 10 participants, judges were quite impressed with their endeavor, with their presentation. So we'd like to thank all of them. Thank you so much for being a great support and great inspiration to this event. And now I would request Mr. Anurag Saxena to please move forward and announce the results. I request you to please do the honors. Over to you, sir.
Good afternoon, everybody. Thank you, Bhavita. So it has been great time since morning. We enjoyed a lot. It has been always a pleasure to interact with young engineers. We also learned in the process. There was a lot of energy, good inputs, and we had very tough time in deciding top three. But all of you are selected. Everybody will get the PPO, but we were asked to choose top three. So first one is Priyanka from IIT Patna. Second is
Congratulations, Priyanka. On first position, Priyanka Kumari from IIT Patna.
second is Sushma from Shipur. Congratulations from jury members and HR team. And third is Vidhi Sachan from NIT Rourkela. Thank you very much.
Thank you so much, sir, for doing the honor. So congratulations to all the winners. I would congratulate once again. First is Priyanka Kumari, and then we have Sushma with us, and on the third, our third winner is Vidhi Sachan. Thank you so much, and we would also like to thank all our jury members. Thank you so much for joining us and doing the honors, and for being with us throughout this event. And now we will proceed with the vote of thanks. I would request Tirna Sanyal from Tata Steel to please join me here on the virtual dais for the vote of thanks. Can we have you, Tirna?
Thank you, Bhavita. Good afternoon to one and all. I, Tirna Sanyal, from TSL's Diversity, Inclusion and HRM Strategy team, would like to take the opportunity to extend today's vote of thanks. It gives me immense pleasure to be a woman in an organization like this and be an active participant in the journey towards true inclusion and opportunity creation for diverse groups. In today's case, young and extremely talented ladies from various T schools across our country. There's a huge round of applause to Tata Steel's diversity and inclusion initiatives. Furthermore, I would like to thank today's esteemed jury members, Mr. Satish Kumar Tiwari, Mr. Surajit Sinha, Mr. Anurag Saxena, and Mr. Shishendu Mukherjee, for taking time out of their busy schedule and giving a patient audience to this enthusiastic group of young women. Next, I'd like to thank the talent acquisition group of TSL and for curating and making this event a grand success. Let me also thank Tata Steel's corporate communications team for their constant, remarkable creative interventions. A huge thank you to Mettle team for providing us your services. A special thank you to Bhavita for conducting this event so seamlessly. Finally, a big round of applause to all the students for their enthusiastic participation. Congratulations, winners. Thank you to our audience and to all my colleagues for being a part of Women of Mettle today. Thanks a lot.
Thank you so much, Ms. Sanya.
Thank you.
A vote of thanks. And once again, we would like to thank all our jury members for joining us and all our participants. Congratulations to Priyanka, Sushma, and Vidhi. Wish you best of luck for the future. And there are more milestones in your life to be achieved, but this one was also a memorable one. Thank you for being part of this. This is Bhavita Singh signing off. On behalf of Tata Steel, we wish
Thank you, Bhavita. Thanks, everybody.
we wish you a
Thank you.
Bye, all of you.